gently
Well,
concede
yeah,
to.
I was going to say, I don't know whether we're live or we are live now, but I was going to say the bit at the beginning that we did about the non contradiction. Remember when I first said to you guys about the logic and all of that, and one of the first examples is the road up is the road down. That they are one and the same, meaning that if you have a line and you put A B and one way from B to A it goes up, and from A to B it goes down. Right? It's the same road, it's the same line. One goes up and one goes down. Well,
Mm-hmm.
in their model, they have both of them going up and down.
Yeah,
That's the law of non-contradiction. He breaks it.
yeah, yeah. That's why that going through the Russell stuff was so for me was penny drop because it's like, yeah, I get it. I get where they're at, where their heads at. It's crazy,
Yeah.
but I see what's going on way more clearly now.
That relativeness.
Yeah. I mean, it's a whole thing. Relativism is a highly taught thing within their circles, education wise and stuff, pushed heavily.
I've got this um Billy and Bill. Um right. The video that I was going to go over today is a surveying one. Does anybody got anything to say about that? I mean, because everybody was fucking brilliant in there.
Yeah.
Thanks a lot, guys. I mean, nobody jumped in or anything. That was really cool. But has anybody got anything to say about anything? I mean, you must have heard loads of stuff in that. And it can't just be Buster and Rakia talking. But hello, any of you talking? Go on.
What video?
No, that one that Bill's just there. I mean, I've got another one, a surveying one that we can go over from Jose's.
Well, I did have a question about. I sent you. I just tagged you in closed text in the other server. A question, but
Okay, let me have a look.
I will say this for anybody who's interested, just something off the wall, because he said mathematics black and white. So I looked up the definition of flat in mathematics. I would say if you want to do yourself a favor, it's pretty interesting. Put in mathematical definition of flat and go to the free dictionary and see what happens.
What I found interesting is when he said that geometry is blurry. The lines of geometry are blurry.
What?
Yeah, he did, but I think he I'll give him the benefit of the doubt. And he said the lines were blurry because he obviously meant level and horizontal, right? When he quite rightly related geometry to reality, but it's blurred because he doesn't know. The model dictates that level cannot be horizontal. So as far as I know, that's where he's. That's where his problem is.
As far as I know, there's nothing blurry between a straight line and a curved line. Nothing blurry about that, Bill. Sorry, man.
He did say that at the beginning, right? He went with the law of non-contradiction. I mean, that's a brilliant way to start off with the way to talk to people.
And then he contradicted himself right after that. Sorry, Billy boy. You're a good guy. I like you. You're polite and everything, but you can't have it both ways. The law of non-contradiction, you can't have it both ways. It's either a straight line or a curved line. It cannot be both, sir.
Mobius, have you got a timestamp of that? Because we can put it on here and we'll get people to confirm if you've got a timestamp.
Oh, well, I've got it. I can throw the audio in there if you want. I got it clipped out. Or you got it
fit in
clipped
the
out,
live
right?
chat. I can't get that on my phone.
Oh,
I don't.
yeah, I think it.
I'm live
Here,
at
let
the
me see.
minute. I don't want to be heading into the closed.
I just wanted to
text
be
on my
sure if
phone.
it was him or not, because I didn't want it's labeled as such, and I didn't want to get the wrong name on there. You know what I mean?
Yeah. Well, I think I can remember him talking about that Lake Pontchartrain the other day. But I think there was some more people talking about it. Sean's there as well, I think.
Well, this may or may not be here. I'll just throw it in there. Yeah.
Throw it in the live chat and I'll put it up there. And
That may or may not be Larry Scott. I think it is, but he says some interesting things in the in there.
right, 44 seconds. If everybody wants to click on it, and then they can hear it for themselves, and we'll listen to the 44 seconds and then talk about it. Right.
That's
And then
Larry for sure.
The Pontchartrain Causeway survey.
Oh, you listened to it?
Yeah, that's Larry.
Klozowski.
Yeah.
I
In
thought
the
it was.
first few seconds. Yeah, that is Larry talking about Jesse. Let's see what
Where
he says.
he, used GPS
Yeah.
and got the same elevation for the deck from end to end. And they say
Same
"See,
elevation.
it's constant
Wow,
elevation."
what a
And then
liar.
They refused to look at the raw data
Right.
that was XYZ coordinates, which were all in the 6.
How can you have something based on the center of the
And
Earth if you don't even
that
know?
returned a constant
Yeah,
distance
that's crazy.
to an origin.
Plus, as we know,
in no point was it
GPS
X,
wouldn't
Y,
exist
or
without
Z.
first order measurements.
meters.
So he's
Yeah, so they don't get it. GPS
wrong.
is based on the center of the Earth.
Yeah, he says it at the beginning, doesn't he? They're all the same elevation. But then tries to reference it to the center of the Earth. I mean,
Yeah, because of the GPS. Yeah.
yeah, that's crazy. And that,
He
they
still
say
doesn't
that
get it.
it works all the time from these satellites. Whereas, like, how would they reference
No.
you if they're referencing the center of the Earth? I mean, what's that?
Well, that's already fucked up. But when we are talking about triangulation, we are talking about straight line triangulation on a flat map. If that works, then it's not a curved line triangle. Because then it shouldn't work. It's that fucking easy.
Yeah, but they're not. They don't triangulate like that with the satellites in the sky, do
Cool.
they? That's, in their theoretical, in Larry's theoretical GPS model, it has nothing to do with the flat map.
They can't
the
locate the center
triangulation.
of a sphere.
Yeah. Yeah, and
They
you
can't
can't
bounce
reference a
signals off of
point
it.
on it by triangulation of things up in the sky. I mean, that literally just can't work.
Yeah, but again, if GPS is claimed to be worked on triangulation, then I don't care what they say also, on the other hand, about the satellite. I don't care about it. If it works, the GPS, based on triangulation, then we are talking about straight line triangle. And that's it.
Yeah.
It's just another question, where is the satellite for the triangulation? That's a whole other question.
Yeah, I mean, that is a different question. I was wanting to know if anybody had got anything with what we just did with Bill before we can put that to rest, before we move on to something else, right?
I missed most of that with
Yeah.
Bill.
Well, don't worry.
Well,
It's recorded.
I'd like to say one thing on the subject, if I may.
Yeah, go.
yeah, sure.
This is what you call a so-called educated person who thinks that he is superior to the rest of us because of his education. And we all saw how he was talking down to everybody. He thinks because he's educated that he knows what a straight line is and what a curved line is better than the rest of us. It's astonishing.
Yeah. But it's shameful, in my opinion, to add something to it, yeah.
Bev says it well. An intellectual snob. Is that how you put it, Bev?
Yeah, maybe. And I call it an intellectual bigot because
Bigot, yeah.
they
Bigot,
they
yes,
actually perceive you as being inferior intellectually, and place you in
Yes.
a group, right? So that, to me, that's a bigot. That's what a bigot does.
Their big problem is that a guy like me walks in, who there's no way I can prove this, but I have an Ivy League master's degree, and I will defer all day long to guys like Buster and Rakia. If I need to get a level line, if I need to have a horizontal surface poured on a property, I'm going to go to the experts and have them take care of it for me. And yeah,
Did you hear that, Bill? An Ivy League man in our midst. Did you hear the humbleness in him, Bill? I think not.
They don't know the difference, right? And they are not used to this kind of talk, in which, you know, we are respecting each other and we are being honest with each other.
They think because a professor told them it is so. That's all. That's it. There's no way around it. If
Professor
it's written in a
hasn't
book,
told them. That's the thing. A professor hasn't
Yeah,
told
by the
them.
way.
Somebody on a Discord channel or in a YouTube
Yeah.
channel has told them, and they have a perceived model, and
Yeah.
their model dictates it all to them.
It's a simple question I have right now. How come that we have PhDs from chemistry, biology, but not from physics or mathematics? In this arena, of course, that's what I'm talking about.
Well, it got me for the first time I
Right.
came in. It was they have to. They're in an arena where they're talking about shape and proof, but then completely disregard the mathematics where you get the proof and the geometry that deals with shape. There is
But they
literally
don't even know
proofs
it.
within geometry to prove
Yes,
shapes.
that's what
I
I
mean,
just told someone. Yeah.
ridiculous.
And they don't know this. A biology PhD doesn't know that, by the way.
Well, I don't know. It's how you're taught to be taught. And most of the people that we talk to are, like I say, intellectual bigots. They refuse to be taught by something. Like, if they don't know something and you do know it, they won't learn anything from you purposely. They'll purposely not learn something, which is, I think it's intellectually dishonest. Sophistry.
Well, if you put it that way, then it might they might have a problem with appeal to authority, you know, because that's what they have to do in university for at least 3 years, right? Straight.
Mm.
So when you're talking, when you're phrasing it that way, that you are trying to make them learn something from you, how about we change that to not learning, but showing them something that they look into at that moment when we are showing it to them.
That's what I try and do, right? I try not to teach anything because I know they put up a wall. They purposely will not learn anything. So that's why I try the Socratic method. You ask them questions that hopefully they'll be able to ask themselves, to answer the questions of themselves. That's what everyone should do, really. Because it's all on the other person, on the individual, to find the truth and proofs of their own. And you can't, I don't
it's the
think
same
you
thing
can
that
be
you-
given them.
That you already said that, actually, in reality, we are individuals. So therefore, we cannot just give you like that the proof or the evidence for something. You have to experience it yourself which in this field means that you yourself look into the proofs in mathematics and then try to think about it logically, how it works, why something doesn't work, and so on.
But yeah, I'm having fun at the minute with the because it is. Is there anything that we talk about that anybody doesn't understand that we just went over with Bill? Because I think that was pretty simple, right? I wasn't trying to push it. I wasn't trying to make it too simple for him. But we do literally have to explain this stuff. Bill had the two ends of the water level sloping. And he also had the plumb bobs at either end not being plumb. Did everybody notice that?
Yeah.
Like, that was just simply because there was a water level there. And either end of the water level wasn't plumb when you had a plumb bob. The plumb wasn't plumb because he had a water level. The only place that it was level was in the middle. That is just ridiculous. But it's no more ridiculous than what I've heard the ballers say. And many, no doubt there will be a cleverer person with more qualifications than Bill that makes similar mistakes. I mean, they all do. They say it's a mistake. It's what their model dictates.
That's what Vich's Peaches said over a year ago, that the only place the water level is accurate is the centre point between the two ends, which is the only place that the water level isn't.
Yeah, but up until
He said
today,
it out loud that way.
yeah,
Oh my.
up until today, we've never had anybody holding a plumb bob at either end and them not being plumb. Like, the water level affects the plumb bobs. I mean, that's fucking brilliant. I don't know how it works. I don't know, literally don't know. I think what Bullet Bill had done is he's got hold of the parallel postulate thing, hasn't he? I'll let me just get this picture
Oh,
just to show you what
I can
I
show
think
him
Bill's done. Go on. Have you got
my
a
little
picture or
video
something?
explaining where is the lying happening in that kind of supposed mathematical problem.
Let me see if I can find. Have you got a video out there? We can watch a video if you've got one.
Yeah, it's a short one. One moment.
Busty, you got your guitar handy?
Has
had to
anyone
run to
been
the store, but
live? Has B-Ball gone out anywhere?
No idea.
Because he's meant to be calling Barry out. Everywhere.
Everywhere. All of 3 Discord servers.
Gem Pandas, was it?
Gems,
Brandon's.
Jose's and Brandon's.
I wish I could find this.
I want to hear the ode to Barry.
You'll have to give me about 30 minutes, but I'll be back at my computer here in a little bit.
You've got to have it as your theme music. Like
I had to break the ukulele out for this one.
Oh, really?
Ukulele. Oh my fuck.
George Foreman, when I'm painting windows.
Yeah.
Here we go. This picture here. That is what he was doing. Except he got, rather than having auto levels, he put a water level there. And because of pictures that the guy from Maine has drawn and made videos about, Bullet Bill assumes that the water level goes up in the middle, but then found out that there was meant to be a drop. He hit the double drop hump paradox and stalled. But that's why his plumb bobs weren't parallel, weren't perpendicular. They weren't plumb.
Yeah, sorry, Bev, you said he made videos about it. Now, he didn't make videos that are showing this kind of diagram in real life, right?
Yeah.
He made video about the theory and the picture, right? Okay.
No. He said he's done it. You will have to. I'll have to show you the video.
Measured.
Yeah.
He said he measured this kind of phenomena.
Oh yes.
Uh-huh.
Yeah. These are drawings that he's done that he's supposedly done. But I mean, if you look there, he's measured 94 degrees and 94 degrees. So
Yeah, we went over it, didn't we? Because he actually had his notebook out, wrote all of his down.
Mm-hmm.
And where did he fuck up in the measuring? Because this is obviously nonsense.
He's not got his plumb bobs at 90 degrees like Bill's shown, right? Because of the consequence of this, the plumb bobs point towards the centre. They're not perpendicular. And if they're not perpendicular, they don't measure 90 degrees. And if they don't measure 90 degrees, it's not plumb.
Oh, so it's simply the plumb bobs were not vertical. That's it.
That's what Bill's just said, and that's what he said.
Suddenly, plumb bobs do not measure vertical.
Mm-hmm.
Uh-huh.
Yep.
That's like, have you ever, anybody who's listening in, heard something like that?
That's all we hear is it's at a point.
Yeah.
Perpendicular at a point,
Yeah, but-
horizontal at a point.
Yeah, but
Yeah,
now
he's-
they've lost that at a point with LIGO, which they say is straight and level. They've lost that at a point because every perpendicular has to be parallel with.
Yeah.
Now they've lost that at a point.
Well, you see, I still give him room for it. All of the perpendiculars to the plane are parallel. We didn't say whether it was a horizontal plane, although he did say that they were on the X and Y axis, which would make them horizontal, and which then would make all of the perpendiculars to them vertical, and
Yep,
all of the
obviously.
verticals being parallel is where their brain sort of fries out. I mean, but you follow the logical conclusions of the argument, the geometric argument. As soon as you put X and Y down there, that's it. Game over. Done.
The one thing that they're holding as a proof for something takes away something somewhere else from them.
Yeah, I said that ages ago, right? All you've got to do is get them to give you something. That's why they never give you anything. Bill, you could see he was very skilled at it. He knew when to avoid and when to not give out anything. Which he didn't. He didn't give up any numbers. You didn't hear him say any numbers, did you?
Well, he was the numbers that were given from his air quotes side. He was trying to say were the numbers that you were giving him.
Yeah, and he was very vague about the numbers and how they get used, and I wrote them down on the board and did all of that. But I mean, that's all you've got to do. As soon as they state anything, they will contradict somebody else somewhere else within their model. They have to.
Mm.
Asking, this is the worst chat for a globe proponent to be assigned to. Yeah, you're dead right. That's why they've all gone. Asking, they've all left.
Could you imagine drawing that short straw with those guys and be like, oh, hell no, we're drawing again. I gotta go home.
I think about that too. Them being in a meeting, going, okay, you got to go to Bev's. Oh, freaking no way.
There we go. Hey,
went to
Data.
Bev's last
Good
week.
evening.
Hey, Data. How you doing, man?
You assigned me to Bev's last week. What, are you mad at me?
What's going on?
What do you think about the law of non-contradiction? Have you ever heard of it?
I've heard it used in the arguments. Yeah. As far as like the full application of it, I haven't practiced it.
It's well, it's the
Give me a rundown.
it's the foundations of the basis of logic. Right? In order to start anything within logic, you need to make a statement. And that statement is either true or false. Right? It cannot be, if it's not it's not a statement if it's not either true or false. Right? If it's ambiguous, it's not a statement. If it's not true or false, right? It can't be both true and false at the same time because of the law of non-contradiction.
It can't be contrary to itself and then be true. Yeah.
Yeah. So the law of non-contradiction is at the basis of everything, and we've decided that if you can't live by that law of non-contradiction, you can't contradict yourself within an argument and then have any basis within that argument, because you could just
kind of like the is it kind of like the Neil deGrasse Tyson doing a calculation for a football deviating a small deviation due to Earth rotating underneath it, and then at the same breath say that a hot air balloon doesn't experience it, a helicopter won't experience it, but a football can.
Yeah.
And
Yeah.
the whole model of the globe is literally founded in this contrarian. I'm going to ignore my senses because that's what I do to be a heliocentrist, is ignore my senses.
Yeah, but more so than that, we're in a supposed debate setting, and you cannot have a basis where you're debating somebody if they can hold both sides of the same argument, and which they just flip and swap around. I mean, that's one of the tactics that they have, that they use, right? So we're trying to
Well, that's what a sophist
point
uses,
that out.
Right? That's a tactic of a sophist.
Yeah, if they can get away with contradicting themselves and you not noticing it, then they will always win the argument, because they'll be able to take both sides of it. Even when they're wrong, they'll just be able to flip and take the contrary position, which they do very cleverly. Some of them are very, very clever at doing it. But Bill didn't even know what it was, or he was acting stupid. I'll probably, let's say Bill was acting bad, because that's what they like to do. They like to get you to tell them everything. Chat's moving fast.
Double speak is what I'm used to, and in a way, they can't operate. They have to get you to the suspension of disbelief, right? Is in the example of the train, in the example of the car, in the example of the airplane. It's all these ad hoc explanations conjured up by man's construct, right? And you're developing this.
What, cars
Like
and
the
trains and
Cavendish.
planes? I don't know. You might be
Well,
going
the-
off on a tangent here.
No, like you know how they have explanations, like they want to give you a scenario of a conservation of momentum, and they want to give you scenarios where you're in a car, you know, you could be traveling at 60 miles an hour, you can't feel it, right? It's so they give you these ad hoc explanations. So in one way you have to ignore your senses, but in another way disbelieve the senses that you're feeling to kind of even understand the explanation. Right. So it's useful, I suppose, for the globe, because there is there is conservation of momentum, but when they apply it to such a grand scale where they can't compare it to anything, and there's no actual demonstration other than the explanation.
Well, that's not a demonstration, is it?
Well, that's what I mean, right? It's a conflation of an observed event, and you're in the process of it. And the same with relativity, right? Is that guy moving or am I moving? That's a floodgate of sophistry right there.
Well, everything is relative. That's the problem, right? You just need to get a track on it. Well, I say everything is relative. It can be thought of as relative. But there are certain set things in reality. Now, there isn't many. But there are certain things in reality that you can rely on as always being the same.
That's why I think there's not this crazy, evil, satanic thing that's, if you look around, we have running water. We have a system that is corrupt, but it could work if people got off their butt and did something about it. They could improve it anyway. Just like we're trying to improve the minds of, doesn't matter you're globe or flat earther, just learning geometry in general is quite entertaining in itself. The story, even Pythagoras's golden verses. Have you ever looked into golden verses there, Bev?
The verses.
The golden verses of Pythagoras, yeah. It's insightful as far as knowing their thinking, their line of thinking, and their commandments, if you will. And they're called the golden verses.
You're going to tell us
Some of them are
stories
logical.
wrote about Pythagoras.
No, I just find it. See, this is what I find really interesting about, 369 geometry and 60 divided by 90 and 60, 90, 30.
They're the numbers.
Equal, right? Yeah, but they all have
Whoa.
significance to optics in some sort of weird, strange, correlated way because it's geometry. For instance, 60 divided by 90 is 0.666. Well, that's how many 8 inches per mile squared is 0.666 feet, right? And then if you take 60 divided by 90 divided by 30, you end up with 0.02, which is the slope factor of the human eye, which is 0.022.
Whoa, you're going off again.
No, just
you
saying
are.
that
You're just
there's
relating numbers to something. Now, those numbers are just numbers.
Triangles. 60-90, buddy. 60-90. 60-90-30. These are all just triangles. This is all like slice and dice.
Yeah,
right?
I know. 60, 90, 30 is the isometric triangle.
Yeah, so you end up with the actual slope factor of the human eye. So that apparent convergence, slope, the convergence of your human eye, that gives you the spatial relationship between objects and the distance.
No.
Yeah, it's 0.022. So that's a slope factor. So when you go to use the Rayleigh criterion,
The slope factor of
optics.
what?
Okay, so as we're standing at whatever height you're at, and you place objects at various locations and positions away from you, you have a spatial relationship and optics to them, and it can be calculated over a graph that gives you a slope pattern, right? Based on the
What do you mean
position of the
slope? How do you measure the slope? Rise over run.
Well, this case is using the slope calculation.
Yeah, rise over run
Right, which is
gives you the
a
slope.
really, yeah, very easy way to do it. But in this particular case, in the paperwork that I've read, it's usually a 0.022. So I find it interesting.
What,
that the
now,
isometric
no,
proportion
whoa,
is
whoa!
like
Don't go any
90,
further
30.
than that. Let's break this down right now.
Mhm.
With slope, the slope is what you're looking at something, right?
So here's reality.
No, wait,
Let me
no,
draw-
no, don't, please,
if we're-
do not.
if
I
we're
want to
drawing-
clarify this right now. You've said slope. I want to know what it is sloping. From where
Okay, so-
to where? What is it
Okay,
that is sloping
right.
first?
Great, I'm glad you asked. So in the exercises, what they've done is they've had a human being standing looking out at 90 degrees to their eye level, right? So whatever their
90
height,
degrees
whatever
to their eye level.
well, 90 degree outward, right? So eye level, right? So
Horizontal.
exactly. So they're standing out looking, and in between themselves and their limitation of whatever distance they're marked off at, they laid objects in the foreground below the observer's eye line.
Yeah, and then
as
so
you
the
move-
slope is then calculated as a rise over run
You got it.
of the object
So-
away from right. So okay, right, let's say 50 feet away, 4 foot down, or let's call it 5 foot, right? It's 5 foot lower than the horizontal set, and it's 50 feet away. So the slope, rise 5 over 50, run.
Mm-hmm.
Yeah,
Mm-hmm.
right.
But
now
here's
we've got that.
yeah.
We've done that calculation. Now you say 0.00. How does that relate to the rise over run for the slope?
Because it's an angular relationship that's constant to objects in the distance, and it seems to have a rate for that.
But the
particular
slope-
eye line.
The slope
Hmm?
was 1 in 10, wasn't it?
So
For every
so
10 foot
the-
you went away, it dropped 1 foot. So when you've done total of
I don't
50
know.
feet, you've dropped down 5 feet.
Yeah, I don't know about that. I'm talking about the apparent rising of the ground. See, this is what you have to keep in mind.
But that's
as
you've
if
just
you're
worked out
going-
a slope.
Exactly. So this.
So
that-
where's the
then it-
apparent? What do you get? Where's the 0.0 come from?
Okay. So the shape and size of the human eye and the aperture and the wavelength of light, they come up with this 0.02
They?
degrees.
How?
Through analyzing the spatial relationship between objects in
Of your
foreground and
eye.
Yeah, exactly. So where they appear.
So they go
mathematically, so
I equals 0.022.
Nope. So they would draw it out, right? And because
Draw.
the
How?
ground
What
is-
would they draw out? Come on, Data. This is what we've just been doing. We've worked out
Love
the,
it.
how far
So-
something is away. We've ended up with a slope angle. How do we relate that to our eyes?
So when they graphed it out, right, you can draw this orthographically, and you can see.
We've
that
just
there's-
drawn it out.
Yeah, exactly. And
We
there's
put
no-
our eye at one end, and then we've done 50 feet one way and 5 feet down.
Yeah, and there's no rising of the ground when you draw it orthographically, right? There's no slope. You're not drawing a rise over run. But when you look at perspective in a linear fashion, you're going to have a slope, an apparent slope factor. And they
Apparent
calculate
where?
into the human eye. The way
You're not
the way that-
mathematically putting something into an apparent. You can't do that with maths, right? You definitely can't do it with geometry. You can't put a
So-
number value to an apparent thing.
So when you're looking at perspective in a linear fashion, there's an apparent rising in the ground. It's not actually rising, but it's no different than the 1 over distance squared, right? In the way it works, but
1 over
in
the
this
distance squared.
Yeah.
What-
So like,
What's
you know,
that for?
take the
Why did you do that?
because it works the same way. It's the
What
rise of
works the
Orion.
same way? 1 over the distance squared works for what? What does it do?
So if you want to look at a slope factor, right? It's an apparent rising, right? The ground isn't actually rising, right? It's parallel. It's parallel to the observer's
No,
eye
the
line.
no.
Except for the
The
ground,
the
it's
ground
appearing to
doesn't
rise
do
up.
that. The ground does what the ground does. You've set an eye line that's horizontal,
Mm-hmm.
right? So the ground will do whatever the ground's going to do.
Exactly.
But you
But
want
there's
to assign a number value to that.
No. So Bev, what causes the apparent rising of the ground into the neutral point of the eye?
What causes it?
Mm-hmm.
Me looking at it.
So you looking at it, what is happening to your eye to make the ground that would be actually, it would be parallel to your eye line, and it actually doesn't rise up, but it apparently converges, right? So what's causing that apparent rising?
It literally,
You said
you're just looking at it.
you,
That's what you
yeah,
see.
exactly. So the way that light produces, it has a slope factor into the eye. There's a convergence, right? It's called perspective point, vanishing point, horizon line. Those are all the limited points of resolution that you and I can understand.
It's just for drawing, isn't it? Perspective is how you draw something to make it look
Yeah.
like it's real.
So the light that is being transmitted from the objects 3-4 miles away.
You're best off talking to an artist if you're after perspective. I mean,
No, I'm
artists
talking- I'm
aren't
talking
known
actually
for
what
the
happens
putting numbers to how they do things. They just translate what they see onto paper, much like a picture does when you take a. But again, there's no number values related to that. You can't. You can't put that into geometry, and you can't put apparent things with numbers on them. You have to actually measure in order to do anything like that.
They once they graph it out, they actually measure the locations and how they apparently slope and then converge into the neutral point of the eye. So they map that out, right? And you can do it yourself, right? You can graph this out and you'll see that there's a slope factor.
A slope factor. Please explain what a slope factor is. Fact is just a multiplication, right? Should we get that? I'll have a look.
It's just the apparent rising, the spatial relationship between objects in the distance. As they move away from the observer, they appear to rise, compress into the neutral point, right? And that's the way we see things, and the way we see things is light going in through the eye, right? So we have angles, limited angles. That's what help us distinguish, you know, geometry and so forth, right? So that slope factor can be
a fact or situation that influences the result of something. So the slope influences the result of something to do with your eye.
Yeah,
when
so
you
have a
talk
limited
about a
angle.
slope factor.
Yeah.
Right. So please explain.
So this apparent rising is calculated as a slope, right? In some eye literature, if you will, they give you a slope calculation for it. And it's because there is a perspective point, there is a compression rate at what objects move away from you based on the distance and size, right? There's a rate, and you can calculate that. And I guess in the paper they claim that it's a 0. One of the papers anyway that I've read was a 0.0.
Yeah, but I know you've read it, and I know you've read the number, and you can recite the number. But please explain.
Here's the correlation. Yeah, so here's a correlation. I mean, 6 foot over 6 miles, 6 feet over 15,840 feet. It gives you a rise over run. If you were times that by 57.30, you'll get 0.0217 degrees. So that rise over run factor.
Whoa. Say that again.
So 6 divided by 15,840 right, times it by 57.3 will give us 0.0217 degrees.
So what was that other one? Times the 3 point what?
So I just want to take my radian values and turn it into a degree, right? So I times it by 57.3. It's a quick way to do it without any.
So wait a minute. So you're going to do a rise over run that gives you what, a ratio,
Mm-hmm.
and then you're
Angle
gonna
ratio, yeah.
you're gonna take
Turn it
that
into a degree.
ratio and turn it into a radian value. Why do you
what
do
degree?
that?
Turn it into a degrees, not a radian value, degrees.
Yeah, but you're assuming that the
I take the rise over run ratio and I turn it into a degree. It's very
Why?
simple, dude. You can do it.
why do you
Because I
take
wanna
a
know the
rise
distance.
over run ratio and turn it into a degree?
Because that's what you do. If you want to take a rise over run and turn it and find out the degree, that's what you do. And in all trigonometry, that's a quick way of calculating the degree. That's what you do. That's just how it is. If you want to find the degree of any ratio of any triangle, you times it by 57.30, you'll get the degree answer. That's what you do. So I don't know if you know trigonometry, dude, but that's right directly from trigonometry.
Yeah, but you don't do a rise over run. Like I say before, we had 1 in 10, didn't we?
Do rise per run, times it by that to get the degree. It's very
So
easy.
if you have 1 over 1 in 10 as your slope.
I'm not talking about that. I'm talking about 6 feet over 15,840 feet.
Yeah, which is your rise over run.
Exactly.
Leaves
So
you with a
that's only one
fraction.
angle.
Leaves you with a
That's the
fractional
fraction.
value.
Yeah, yeah. If
Yeah.
that's only one angle to the eye, and I have another 0. Because that's the bottom part of the eye. The top part of the eye, I have another 0.217 degrees.
Yeah.
That works out
Wait
to
a
be
minute,
0.
Data.
That works out to be 0.
Data, you're not helping anybody here. Everybody's listening.
Degrees,
Data,
right?
please stop it. Everybody here wants to know how you get a rise over run calculation and develop an angle from that. How does that procedure take place?
You draw a triangle.
Yes.
So again, their slope factor produces a apparent triangle to our vision. The ground isn't rising, right? You
No,
can have,
no, don't
Yes, yeah.
try swapping Data. Please
I'm calculating
explain.
rise over run.
We have the triangle. We have
Uh-huh.
the rise at 6.
Mm-hmm.
And then we have the run, 1,500 and something, yes?
Mm-hmm. 3 miles.
Yeah. And what we do is we make it rise over run, which gives us a ratio, right? Of the amount that you travel and the height that you rise over or drop over that distance, right? Now, how do you get an angular measurement from that number? Please.
I convert those numbers to degrees by using the 57.3 to do it.
So, and what do? You just times it by 57, do you?
Yeah, there's other ways. Just that's a way to do it without a calculator, right? To do it without other tangent or a sine or whatever, or if you want to do it other ways. That's just a quick way without a calculator.
Right. So, what do you sort of imagine that? Which angle is it that we're talking about?
So if we drew a
Which angle of the triangle is it that we are talking about?
So if we were to draw an observer's eye line,
Is it the angle at the eye, or is it the angle in the distance?
the right angle would be the eye.
No,
The
the
90
right
degree-
angle would be at your feet.
No,
Yes.
no.
Yes, slope angle
No.
is your height, 6 foot,
the ground
and
is-
the
the ground
distance away from you is the other distance.
Just imagine the.
No, I don't need to imagine anything. You already told us. Slope angle, rise over run Data.
Yeah, exactly. The hypotenuse is the run.
No, the hypotenuse is the slope.
Exactly. The run.
No, the run is the distance it is away that you had in your calculation for the slope.
And if you drew it out, the triangle, would have the slope at the feet going up to the top of the 90 degree from the eye line. That's how you draw the triangle, and that's what would make the 0.21.
But you make a slope from the feet to your eye line.
Well, you would draw the triangle like that as the observer's eye line is the 90 degree right angle looking outward, and the slope would slope upward from that 90 degree to the point of convergence. This is how you would
The
draw.
slope would slope upward.
Okay. So here's how you can think about it, Bev. Imagine a long
Data. Whoa, no, I think I've had enough, because
I don't know
you don't actually know what you're talking about, do you? You've just read something in a book and you're just spouting shite.
Yeah, no, dude. Look, you can read it in the book. They're just quick calculations for triangles, rise over run. It's the apparent.
You don't do rise over run and then times it by 57, because that's a fucking radian value.
Yeah.
You don't do that. That's not trigonometry. That's not got anything to do with trigonometry. Never has and never will.
Yeah, dude. It's a quick way to do it without a calculator.
Oh my.
Data, I don't know how long you've been getting away with this sort of shite. Really. I really don't.
They let him.
I'm gonna make a brew, but
Yeah, so just
I'm out. If anybody else wants to try and see what Data
you
is
don't,
trying to say.
either you're full of shit or you just don't know what you're talking about. If I did the arctangent of 6 divided by 15,840, why do I end up with 0.0217 degrees? And I'm doing it the same way. I'm just doing a quick variation of the arctangent. What's your guys' problem, man? Like, it's either you're just full of shit or you don't know what you're talking about, and then you're trying to bluff it off like I don't know. I'm actually writing these calculations down, dude, and exercising them, taking screenshots, and applying them in reality. And then you're telling me I don't know what I'm talking about, but yet every time I can fucking back it up, just like the law of sines. Like, what the hell's going on here?
That's not what you did last time.
Yeah, dude, I wiped the floor with you because the law of sines is exactly what I did, what I demonstrated, and my numbers worked consistently. And you guys were like, well, where's your right angle triangle? You can't calculate it. And then Buddy goes, well, I guess you can use the law of sines to determine without actually a right angle. And then you're like, I didn't invent this shit, dude. I just used the formulation. You're telling me I was wrong when I used it in reality? Dude, I didn't do one step
You could
wrong.
use.
Not one process.
Okay, walk us through it again. Walk us through it again. Walk us through it again.
Okay.
2 observers, 2 different locations. I take 2 angle measurements. Those are known angle measurements. Then I know the distance between the 2 of them, right? Then I take the distance, right? Then I multiply it by the sine of the angle A divided by the sine of the angle B, which I get when I find
angles to what? To what?
So listen,
what are you looking at?
Are you ready?
I'm gonna show you in a moment. I searched it, but
We're looking with the line of a
get the
sight
picture.
from 2 locations with the human eye, and I'm measuring the angle from my line of sight to the peak of the mountain.
What are you looking at?
The peak of a mountain. I'll talk.
You're looking at the peak of a mountain.
I'm looking at a peak of a mountain. I am taking 1 angle measurement.
Do you?
Yes.
Do you need to be so condescending? Do you need to be so condescending?
Michael.
You know what condescending is? You know what condescending is? Asking me if I can explain it again.
Calm down.
Asking me if I can explain it again is being condescending.
Why are you so upset?
Because you're just a moron, dude. Wasting my time. And these people on the channel, I'm trying to teach you guys shit, and you guys are fucking fighting against me, and I can back it up.
Hey, buddy.
Shit,
calm down.
Hey,
calm down. We're here for you.
Calm down. Tell me more. You're here for me. Tell me more. Tell me more. Sweet little words, bro. Come on.
It's in the
again, Data.
Yeah. Go ahead. What's up?
Data and Michael, the picture is in the live chat, so you can talk regarding that. You can sign everything that you want when you're talking about it. Okay?
Yeah, and I didn't invent that, and there's nothing wrong with what I presented there. Where's the mistake?
Very good. Do you remember my question? Maybe.
Your question is invalid if you thought that this stuff that I was showing you was incorrect, because you have no opinion. Because at this point, you still haven't conceded that what I showed was correct.
I was asking I was asking
Melody,
about
I'm gonna ask you to
last
clarify.
time that
Did
I
I
had
show
a
you?
question.
Did I show you correctly how to use the law signs here? Yes or no?
No.
Okay, so what did I do wrong with it? I'm willing to learn.
I
Tell me
asked
what
you
I did
last
wrong.
time.
No.
Okay. I asked you
According
last.
to the professor who had the instruction, you're taking critique with his instruction, not mine. All I did was use his formulation and recopied it, but applied it to my reality. In other words, I took two real measurements and a known
I get that.
distance
I get
between
that.
those
No
measurements.
problem there.
So
No
yeah,
problem
no problem
there.
there.
I
But where
watched the
did
video.
I get it wrong? Where did I get it wrong? Because guess what? The
Well,
actual
if you would
measurement
let
of
me
the mountain.
answer.
This is a
Did you have a question,
conversation, Data. Let just back and forth for the
Yeah, but dude,
for the love of.
it's so douchey.
You're
It's
even
like
cutting me off,
Sorry,
trying
did you
to
have a
get you to
question
shut
to
up
me?
for just
Did
a
you have a
second.
question to me?
God.
Did you have a question to me? Because as I heard, you had a question. You won't let me answer, right?
You said no. You answered it, correct? So then I asked you
No.
where. Yeah, you said no. I
You are
didn't
just
explain it
lying right
correctly.
now.
Dude. I said did I present it? Where was I? Anyway, I asked you if I presented it correctly, and you said no, right? And I want you to clarify how I didn't
Yeah.
present it correctly. So how did I used exactly what the professor did, except for I applied it in reality. You agreed that that wasn't the issue. Me applying it to reality wasn't the issue. So
No, no,
what's
no.
the
I didn't
difference?
say that wasn't the
Hold on,
issue.
just to clarify,
I
you
said
have
that
the issue with
it
the
was a
professor
problem.
or with me?
Yeah.
Because it's
Both, by
not
the way.
mine.
Both.
Oh,
Yeah.
both, by the way. But when
I know.
you
I
can't
know.
have you can't
Yeah.
have an issue with me. It's not mine.
Dada. Honestly,
You understand?
Dada.
This is
If
why
I
I'm
do, of
contentious
course.
here
I'm not
because
talking
it's
about
not
that.
mine.
I'm not
Dada.
against you,
It.
man. I'm
Mic
not
check.
against you.
My mic working?
Okay.
Yeah. But
Dada.
you are, right?
Mic check.
I
No,
muted him.
I'm not.
He can come back when he can
I
calm
just
down.
had
About
a
5
simple
minutes.
question. I just had a simple question last time. What is your distance on this picture that we see?
3.9 kilometers.
That's right. And the distance is in between what?
So angle 1.
Yeah.
And then angle 1, I get what I can't remember, the 6.58 degrees. And then angle 2 is.
No. I'm asking about the distance. What is the
Yes, so
distance
I
in
take two
between
angles.
the 3.9?
Listen, you listen. I'm taking two known angle measurements and a known distance. This is more than enough information to calculate what I need for a hypotenuse. This is why
What is
I can use the line. Listen,
the
this is
distance in
why-
between?
Hold on, dude. Listen, I'm not making this up. It's some of how weird you're in denial.
I know.
With these
I
two
know that.
angles and the known distance, they're not made up angles. They're actually known angles measured to something in the distance based on line of sight. The law of sine says that I can
Okay.
do this and develop a hypotenuse, which I did. And then my calculations, the results, the real height is 868 meters. My height, line of sight with the eye and an iPhone, 820 meters. That's not terrible.
Very good. So, what is the distance in between?
Dude, are you deaf? 3.9 here's the calculation. 3.9 kilometers.
No, that's not what I asked. What are the
9A,
2 points?
which is 6.58
The two
meters,
endpoints
divided by
of that line.
9B, which is 7.71 degrees, and then you'll end up with your hypotenuse angle A. Angle A, you can take.
I'm only
now you know the second angle.
asking
So you have
about
your
the
hypotenuse.
distance. What is
I'm teaching you how to
that
do it,
distance
dude.
that you measured refers to? That's only what I asked, nothing else.
So it refers to a necessary part in knowing how to calculate the hypotenuse between the two angles.
Regarding
I'll
your
give you an example.
measurement, what it refers
I'll
to.
give you an example. If you take a
Isn't
camera,
that a
okay?
slope distance? What's up?
No, we're not calculating slope here.
No,
We're
that
just
is a
calculating
slope
an ang-
distance.
Yeah. There's no calculation for a slope. That's against a horizontal.
No,
we're not
that
calculating in
is
perspective.
a slope distance. Is that what you're trying to get at? What's up?
No, not me. You were trying to get at it last time. I'm trying to get at something else now. Because he doesn't realize he has two problems. One is yours, and the other is what I'm trying to get at right now.
So the point of the matter is that it's not far off from the actual true calculation. Now, your
Okay,
argument
but
is
I
that the
didn't
land. Hold
ask
on. Your
anything
argument is that the
regarding
land.
that, did I?
Your argument is, yeah, but your argument is the land is
No, that's not my
uneven
argument.
between 2
Sorry,
points, right? Well, then your
that's not my
issue's not
argument.
with me.
Sorry.
Your
No.
issue's with the professor, dude, because I used the exact professor
Yeah, but
steps.
you are here
In
representing
reality,
what he does, so I can only talk to you
no,
right now.
I'm
I
representing.
would talk
I'm
to the
representing
professor,
what
by
I.
the way.
Yeah, I'm representing what I did in reality, right? I took his
Okay.
calculation, which is not actually his. He didn't invent it, right? So it's called the law of sines. It's really easy to do now that I've tried it.
Again,
You can do it a
this
couple
is
of
the
times. You start to
fifth
understand
time
it
that
better and
I'm
better.
asking what is the distance, the 3.9, what is in between?
So in between is the known distance between the two known angles.
So those are the 2 points we are talking about, in which one you first measured an angle, and then the second point you measured an angle, and there is a third point in this picture, right? Where is the right angle,
The third point
right?
is the angle B, which is the top of the mountain. And when I know the distance
No.
between
I'm
those,
talking about the same line.
look, I'm
On
not
the
sure you
same line,
understand
there
how
are
this proof
3
works.
points on the very
I'm not sure.
bottom line,
I'm not
right?
sure you know how this
Let's be
proof
very
works, dude.
simple with this. On the very bottom line, there are 3 points. One
No, there's 2
distance
points.
is measured by those
There's
3
2 points on the bottom line.
No, there is
There's
3.
two. There's 2. There's observer 1, observer
What
2.
about the
That's
right
it.
angle point? What about the right angle point on the right side?
Okay, so again,
Isn't that a
there is
point?
only draw one big right angle triangle, bro. Draw 2 points on
Isn't
that
that a point?
tangent line. Draw 2 points on that tangent line, and then draw 2 hypotenuses to the top
Mate.
from those 2 points. Just
There are
copy the
3
picture.
points on the
It's
bottom line.
it's too complex for you. I don't know, but it really
No, Data,
No,
it's
it's
not
not.
too complex for him at all. I can see,
Well, he's
yes,
not getting
what's
it,
up?
dude.
I can
There's only 2
see
points.
there are 3 points on that bottom line. I know Data's not acknowledging it, but yes, he's got a picture
No,
there.
there's
There are
2
3 points along the bottom of that triangle.
Yeah.
Yes.
There's 2 that you're
There is
only
a right
interested
angle
in.
on the right side.
Yeah,
So
you're
there
not
is the third
interested in
point,
that
right?
angle. You're not interested in that angle.
Well,
It's
how come?
imaginary. What you're trying to do is determine the height of that
But you draw it.
mountain.
Why did you draw it then?
Mountain based on your position, right? So
Why did you draw it then?
you're going to get a relative position.
If you don't
You're not
need
gonna
it, why
get
did you
100%
draw it?
position, man.
Please tell us.
Because I wanted to see
Please
if it works
tell
in
us, why did you
reality, and
draw
guess
it?
what? It works in reality. Pretty cool, huh?
Then there you have 3 points.
We've
You are
done this.
working off of 3 points.
Hang on,
don't you?
we've done this
You're talking
3
to me about
times.
3
We've done
points.
this 3. Hang on. We've done this 3 times. Can I just ask what for?
Yeah, no, it's not what for. It's the point is that I present a situation where you can calculate the height of an object without the well, they're claiming that it's faulty because you need a right angle
No, he
triangle.
finally got told by someone that he doesn't know the second distance on the same line. And there is his problem, by the way. That's what I'm trying to get at.
Determine that, and after you
He doesn't.
after you get the
You don't know.
after
Let
you
me
get-
rephrase. You don't know from
after
the
you get the
first point
hypotenuse
to
and the
the
angle,
last
you can get
point
the
on the
distance.
right, the distance, do you?
Sure, you can take the hypotenuse and the angle and get the distance or the height.
Do
height
you
of the angle,
know
you can
the
get the
distance from point A to the right angle point?
Yeah, you can add all that up. Sure.
How?
You take the height now that you've developed and you divide it by the a degree, and you should get the distance along the tangent. There
You need
from-
that for the height.
You have so listen. You have all you need to know, right, to determine the distance to the other mountain now, or the distance from the second observer. So you're looking at like 3.6, 3.3 kilometers. Hold on. Let's do it real quick here.
Has he gone quiet, or is somebody doing maths?
He's done maths, but
No,
he
he's
did
doing
the first time he
something, I
brought
don't know.
the first time he brought this, he was stating that he had the distance of what What's Up's asking for, but now he's
So
not
what's
doing that.
3,107 meters? What is
Yeah.
that? So that would be the answer, right? So it would be that far away. So you take that to convert it to kilometers, and then you would add the 3.9 kilometers. that you've driven,
Wait a second, wait a second.
and
Did
then
you
would
just
know
ask
that whole
me
entire
what
distance.
is that number?
Yeah.
Who did you ask
No,
that
I
from?
didn't ask. No, it's just
Who did you ask that from?
Didn't ask anybody.
Who did
Not
you
the
ask that from? Because it certainly wasn't me or anybody in this chat, right?
Ask for what exactly?
You just asked about the number if it's right. 3,000 something. You heard that, right? Everybody else.
Yeah.
Well, I'm just looking at meters, right? I have to convert it to feet. Just give me a second.
Who did you ask that from?
You have
That's
to
what I'm
convert
interested
it to
in.
feet. You've got 9 meters and 17 meters already on there.
Wow, man.
And
You just exposed
3.9
yourself, you know that,
kilometers.
Yeah, I don't know meters into feet.
Who are you talking
or
to?
Kilometers, sorry.
Data.
You are talking to someone, right? And you were
Yeah,
checking if the number is right, right?
Well, if you're doing the math with me, why wouldn't I check with you if it's correct? Because we're on the same page. I mean, it's normal. Right?
I'm not doing the math. You are doing the math with someone else.
Yeah,
Maybe
nobody
in the
else
room or-
divides fucking ratios of slopes into numbers to get angles. Like that, you can't do that.
Yes, you can totally do rise over run that way. Absolutely.
Data.
Do you know why I didn't create it, dude? Again, this is bizarre. I'm using what I've been taught by other professors and institutions that teach
You
trigonometry.
haven't been
mathematics.
taught. You looked it up.
trigonometry.
You looked it up.
Sure.
You looked it up.
calculus,
No one
all that
taught
stuff,
you
yeah.
this.
So if I'm learning these techniques from other people and you're not agreeing
Okay.
with them, that's interesting.
We're just trying to learn. Data. Can you not express it?
Yeah, I'm learning these techniques, right? Because I'm trying to figure out how to.
Yeah,
quantify
but
the
when
human
you
eye
come to explain,
into
you
a-
just
into-
say
into a
you say
geometrical-
loads of numbers really quickly, and then when we go, whoa, what did you just say then, Data? Please explain. You can't explain what you've just said.
Dude, I totally can explain what I just said, dude. You guys are either out to lunch or just too slow. I don't get it, man. If I tell you that a 6-foot observer in over 3 miles is a run.
You say that one more time, I'm gonna server mute you forever.
Yeah, but dude, why am I being
It's
told that I
right.
don't know
No,
what I'm
yeah,
talking
but-
about? And it's like,
No,
come on,
yeah,
man.
but
I'm,
you ready? Did you hear me clearly? Say that one more time and your server muted.
yeah, you guys are like refuting stuff that I've learned from professors and quick ways to do calculations and measurements, optometry work. Like, dude, I'm not.
Go
I
on,
didn't
which
invent any of this stuff that I'm
professors have
presenting
you
here.
learnt this from? Because if we're supposedly
online?
refuting it, please tell us the names of these professors, and we'll see if we can
Michael
have a
Van
chat with them.
Beesen's
Because
one.
I'd love to have a chat with
Mike-
people about this sort of stuff.
Awesome. Michael Van Beesen is one. Little short dude with a bow tie. He puts out videos left, right, and center. There's Khan Economy. There is.
So you mean you've watched videos on YouTube?
Does that make you feel better?
Well, no, that's what What's Up said earlier, and you said no. I've been taught by
Oh, dude,
professors.
That's correct. Yeah. They
Right,
tell
so
you what,
have you been taught by
I don't-
professors, or have you watched YouTube videos, Data? Which one is it?
I've been taught by professors on YouTube. How about that?
You've watched YouTube videos and
That's-
presume
that's
you've
very
been
good.
taught by professors.
So-
Brilliant.
Yeah, so I've been taught by professors on YouTube, and somehow that's comedy to you guys when you're here trying to learn on YouTube. Come on,
Yeah.
man.
Trained
That's
by
not a
Lawrence
comedy,
Krauss.
that's how you
If anything, be
phrase it.
genuine. Yeah, I can phrase it beautifully, just like a little princess with a crown, man. I can make it all sweet and candy sounding.
I mean, we
You
didn't
guys,
ask for
you guys
that,
are
by the way.
stuck on me trying to present stuff that it's not mine and work out stuff in reality, and I'm being told that I don't know, but yet I'm exercising it, showing you calculations, and these are not my formulations. These are not my things I've invented. I'm just using them, presenting them.
I'd
Sweet,
say
and
you're
it's funny.
using them wrongly.
Okay, sure. And yet they work out the same, right? And I'm
What do
using
you mean
them in
work
wrong-
out the same? But
So if
what?
I'm
They
using
were
them
doing
wrong-
what?
Exactly. So if I'm using them wrong, then they wouldn't apply to the answer. The thing is,
What
I learned
answer?
these techniques, degrees, figuring out rise over to render degrees, figuring out slope factors, figuring out a form of like it's pre-calculus where you figure out your slope. And,
Brilliant.
It's just
For what
all
purpose, Data?
Well, you have the lens equation, you have the inverse.
For
parallel,
what
you have
purpose, Data?
for all optics, buddy. Just understand how the eye works and how geometry is
Well,
derived.
I understand that I can look at things and I can see what they are. And then I can explain the objects that I'm seeing using Euclidean principles, 3 dimensions. I can describe them using the experiences. I can describe them geometrically because I know. Right now, I can do that with my eyes. What are you doing?
Trying to mathematically quantify that.
Trying to mathematically quantify optics.
Yep.
For what purpose?
There's nowhere in the written documentation in the world called perspective that expresses perspective as a rise over run slope factor into a compression point where you have an apparent convergence. Nowhere is perspective ever labeled, listed, or discussed. The only matter that is ever discussed is in psychology. That's it. In video games, it's expressed as egocentric distance. In robotics, it's a major problem. That convergence, apparent rising, joining, cone of vision is a real mathematical challenge for artificial intelligence. So they understand it. I'm looking for a simplistic way to educate people that it exists and have a new definition for perspective.
Right, well, so you're going to use the law of sines, a known trigonometrical principle of right-angle triangles.
No, it's not law of sines. You would basically have to have a couple of functions. You'd have to have the wavelength of function of light because a certain
Well,
amplitude size.
what's the difference
Right.
between
And you
what
would
the
have to
law
have a
of sines does
rate of
and what
induction of
you
light,
do,
which would be
Data?
based
What's the
on
difference?
square law. What?
What's the difference?
What's the difference? What do you mean?
Well, when you doing the law of sines to work out how tall a mountain is, right? That mountain's already known as a known height. It's a known position. Everything's known about the mountain, right? So we already know everything. Now you're going to stand a distance away from the mountain and come up with something which is a perspective thing, right? Now, how does that differ to us knowing the position of wherever you are and the position of the mountain? How does what you do relate differently to that?
Yeah, doing this law of sines has nothing to do with the perspective.
No, I'm talking about your perspective thing, right? So what is it that you're trying to come here and tell us about? Or are you just coming round here to tell us about the law of sines?
Well, no. So what I came here originally to do is multiple things, was to discuss whatever, trigonometry, whatever perspective, whatever things, whatever's on the menu, so to speak.
Great. I have a
In
new
this particular
question.
In this particular case, I brought the law of sine process so that I could
Great.
use it as a flat Earth proof, because I plan to do it over a certain area where it's all based on straight lines and angles, and the only way for them to conjoin and to meet up. Now, granted, you're at different elevations.
All right,
like
all right,
Alexander
Data.
said-
You want to do a flat Earth proof using the law of sines? Brilliant. We're on it.
How
we get
how
it.
do you know angle B, by the way?
Well, that's where I came. That's what I came here for, and I got shot down for it. The idea was
No. How
not
do you know
build
angle
any
B?
of the- It's not. You measure it with your line of angle B is subtracted by the two angles. So if you take angle angle C and angle A and subtract, you end up with angle B.
Well, how?
And well, you take two known measurements, you subtract them, and you're left with one angle. That's angle B. That's how the law.
Why
of sine
would you
works.
subtract them?
That's how you get the angle B.
No.
That's what you do. To
Why
get angle
would-
B, you
those are two
subtract
big-
them. To get angle B, you subtract them. That's it. That's all your answer is, dude. Don't ask me
Why
why.
would you subtract them?
Because that's what you do to get angle B. That's it. There's no negotiation.
Who
To get
told you
angle B in the law of sine, you subtract the two angles, angle A and angle
Who
C.
told you that?
Subtract- Yeah, go figure.
I
it
just realized, by the way, that there's a third problem there. So,
It's
how
got
did you get angle
problems
B?
all over the place. Come on.
So
No.
again, it's not- you're gonna have to
I
bring
want
up
to
the
hear
professor.
why is angle B 7.71? Okay, I get that you
take
subtract
angles-
it, but
you take the
why?
larger angle, because that's how you get. How do you get angle B? Tell me how. I tell you how. You subtract angle C from angle B or angle A, and you get angle B.
No.
That's what you
That's
do.
the function that you do. That's not the why.
That's what you do. To get angle B.
Again,
that's
that's a
what you do.
function. In mathematics, an action called a function. It's not the why. It's not the
Yeah,
proof,
just
and
write
it's
this
not
out.
the explanation.
Just write this out. Sine A divided by little a is equal to sine B.
I'm not
divided by
writing out
little b.
anything unless you can
Sine
tell
B
me
is
how
equal
do
to
you
little
get another angle that you didn't measure.
How you get that angle is because it's part of the one line of sight. So if you have one line of sight that you point your eye at, that is an angle there. To get that angle, you subtract angle C and angle A to get angle B. That's what you do. Didn't you know how triangles work? That's what you do. So
What, you
I'm not certain if you know how to work
subtract
with
angle
triangles.
C and angle A.
Yeah, to get angle B. Yep.
You subtract angle A
Okay.
and C from what?
From each other.
What you?
From each other. I get that, but I
No,
do not
wait,
get
no, wait a
why.
minute. You subtract angle
listen,
A
are
from
you- are you
angle
bringing- Are
C.
you bringing up the issue that I didn't create? I didn't create the process of the deduction here. They did. The Greeks did. So you have an issue with the Greeks.
No,
not me.
he had two
I didn't
angles
conjure listen,
by the
I
get-go.
didn't conjure this.
Yeah,
yes,
he
had
measured
two
the,
angles.
he measured
You take
angle A and angle
you-
C. Yeah.
You take angle 22 and angle 10 and you subtract them, you end up with angle 12. That's what angle B is. Okay? Guys, this is the Greeks
Angle
did,
12?
not me.
What?
You guys are like
Dude.
struggling to know what the
Can I,
Greeks did.
Data? Can you just
I
stop for
didn't
1
invent
second,
this.
please? Right.
No
I'm
Greeks.
just
No
gonna.
Greeks.
I'm just gonna
No
formulate
Greeks.
this
I'm just-
for myself with what's up. Right.
Okay.
What's up? Right. Okay. Now we've got the small triangle. It's a right angle triangle. We've got 14.19. We've got the right angle 90.
fine.
Right. We add those together. And we subtract that from 180 because we know triangles have
Yeah.
Yeah.
one.
That
That
didn't
gives
come
us that
separately.
top angle.
That's okay.
Data, please be quiet. That gives us that top angle
That's right, yeah.
within the smaller triangle. Now, then what we do
Yeah,
is we presume it's all on the same straight line and it's a similar triangle. We do exactly the same with angle A. Right?
So again,
From
guys,
it. And then we get the big angle at the top. And then we subtract those two big angles, one from each other, and then we get that angle. Now, the problem he's got is that line along the bottom is not a straight line. So you cannot do what we've just done because that is not a similar triangle for working out that angle. That's problem
Here's
probably
the thing.
about 12 along
Here's-
the along
here's
the
why-
line
here's-
that Data's got.
here's why-
Now, apart from the fact that Data doesn't seem to know how to get the angles, he seemed to think it was angle A and angle C, and minusing them from each other to get the 7, which I don't think it is.
Certainly not right.
So that's what you do. 'Cause
I mean,
didn't
you
invent
could
it.
also use the 6.58 angle and the straight line from 14.19 all the way over to get the big angle at the bottom. And you know that triangles have 180 degrees. You could do that again. But that isn't a straight line. It's 17 meters, 9 meters, and the right angle, I'm presuming, is at the bottom, 0. But, I mean,
Yeah, so
Data
the
doesn't seem to
angle-
know any of these things, and it's not a straight line.
Angle takes care of that. So the way that
No,
way
the
that
angles
this
do
works-
not take care of that, Data.
Yes, then the elevation wouldn't matter, then would it? So if you are concerned about elevation due to angle, I'm telling you that the angle based
It's
on
not the
takes care of
elevation
it.
due to the
So,
angle.
in
It's
other words,
just
your
the
elevation,
elevation data.
your elevation doesn't change. Listen, your elevation does not change the object's height in the distance. Your elevation doesn't change the distance to the object in the distance. Your elevation gives fuck all of what the object is in the distance. Nothing. So if you change an elevation, your angle compensates for that. For the lower angle versus the higher angle, it will compensate that. That's why you get a different angle. So it won't change the distance and it won't change the height
Data.
of the object with your measuring.
Data,
So
you need
it
to
doesn't.
sort this act out. I mean, this
Your
isn't going to
elevation-
work.
Your elevation doesn't change your
This isn't going to work. It might work, and it might have worked for a few years, but it's not going to work anymore, mate.
Yeah, I'm
There's-
certain you know what you're saying here because I'm not presenting anything that's inconsistent to what people who practice this for a living use. And as I demonstrated,
People
that
who
anybody willing
practice
to do
this
the
for a
same thing-
living.
Yeah, teaching, trigonometry, pre-calculus, all that stuff, right?
That's teaching.
Yeah, sure. They're practicing it, right? You got to
There's
practice.
a interesting back
No,
and
that's
forth
not the
Mobius is
practicing.
having in the chat.
Oh.
Yeah.
Anyway, I don't know what your
I'd check
guys'
it out.
contention is because it's not my stuff. It's not how how I came up with it. I'm just copying what they did.
Which
So you
chat?
guys actually have issue with the institution and what they're teaching, not me. Like, I'm not
Yeah.
doing anything deviating from what is instructed in here and how to do the calculation.
Your diagram's misleading on the face of it, so
I understand your point of elevation, but again, that is superseded by the point of the angle. Your angle changes on your elevation to compensate, right?
Okay.
And so
Okay.
if you're at an
Okay.
elevation, you're going to measure that in
Okay.
your angle, right?
right.
Where?
And I'm actually a
In the
big fan
YouTube
of
chat.
trigonometry
Oh, in the
and
YouTube chat.
calculus and all that
Yeah, Mobius might want to talk about it. Pretty interesting.
Well, Speak Truth. I mean, is that the Speak Truth? We said we'd go over there and have a chat if he wants to come over and talk about it.
He already said that he's not to be confused with Speak Truth, Seek Truth, or whatever that guy.
Oh, right.
Still interesting though.
But yeah.
Oh, I've just seen there the curved datum.
Yeah, curved sea level datum. Who knew?
That's the point. The at Newland, that one. It's in the UK. That point's curved. Interesting. I've never heard of that before. I mean, what sort of truth's he speaking? A curved point I've never heard of. See if I can find that.
Well, they've got lines at points and curved points and all kinds of crazy shit.
Yeah,
Why
that
don't they ever use
point.
spherical geometry? I would love for them to start using spherical geometry. That would be awesome.
Wow.
What?
I don't know. Ask them how. I would just love for them to start using it. To get off our turf, man.
There you go. Let's see. What's
I mean,
that?
I can assume that they're listening to the YouTube as they're in the live chat on YouTube, right?
Yeah,
So, Speak Truth, I gave him a link to the Discord.
yeah, he says,
So
Bev,
you
you
can-
should read the OS document that covers it. I'm going to do it now, right? I've got the UK National Tide Gauge Network at Newlyn Tidal Observatory. And it states the UK fundamental benchmark, fundamental being the base one that they start off with, says the Tidal Observatory was established to determine the mean sea level, that is the starting point for levelling in the UK. This brass bolt is the benchmark for the whole of the United Kingdom. That is, all heights are referenced to this point. The height of the benchmark was established over a 6-year period from 1915 to 1921, when visual observations on the water level of the tide staff were made every 15 minutes, 24 hours a day, 365 days a year. From the data collected over this period, mean sea level was found, and this vertical level transferred to the head of the bolt. So it's the point that all heights are referenced to. Points can't be curved. It's just a point.
Oh, now he wants you to read the document about the coordinate system.
Yeah. It's just a point.
Is this Larry? Is Larry under a sock account?
Oh, it might be. Huh.
Well, I mean, like, I just go off that point. That's the brass bolt for the old time. I mean, old school. I mean, that's what we do. And then when you check how they referenced all of the benchmarks all the way across, they just spirit leveled them from that point. But, I mean, it had already been done in Liverpool at Victoria Docks. So they already had a benchmark. They just needed to be able to reference that one to the earlier points down at Newlyn once they swapped it. And then obviously change all of the heights to reference the one down there rather than the original one at Liverpool Docks. And then everything's referenced to that one point. I mean, I don't see what the problem is. I don't have a problem with it at all.
He wants you to read the myths.
Oh, he wants to read the myth too.
So the colloquial language
Yeah.
in whatever book is not fact. Just so you guys know that. Speak truth.
Yeah.
Or speak whatever.
That's why I tried to get in contact with them about that one particular myth. Because they say level isn't horizontal. Well, I say I can prove that level is horizontal. It's no biggie. I mean, other people may say differently. I mean, you should be able to just go, simply not. No, I've got my proof here. Look, boom. I've already done it. Curving water levels. But, I mean, everyone I've ever asked, apart from crazy people on this internet, they say level is horizontal. There's only a couple of people. Well, there's a couple of people that purport to be surveyors, but I mean, like George, he's gone. Can't be seen. Jesse, he said that the water level drops away from horizontal, so he seems to support what the Ordnance Survey says, but I mean, he's got no proof other than looking over a lake saying it drops from both sides. I mean, but sounds ridiculous. It's against the law of non-contradiction. You can't have something dropping from both ends of it. It's just unbelievable. Can't happen. Bev can't prove water is flat, Batman. He never said that. You guys are obsessed. It must be the flat earthers. Level is horizontal, Batman. I can prove level is horizontal. Stop thinking about your flat earth. It's not flat, Batman. The earth is not flat. Neither is water. Level is horizontal. And a water level is a tool for establishing a horizontal plane of reference. Only when it's at rest. In a static state of even altitude. Who says that sea level's curved? It's a point. Mean sea level is set at a point in the UK at Newlyn. I mean, try somewhere else. Dude, try another place. You can't do the UK. We have grid reference and we have a one reference datum point at Newlyn. It's pretty simple. A horizontal plane is a two-dimensional surface. Yes. Flat is also a two-dimensional surface. Yes. And the old school meaning of flat used to mean horizontal plane, yeah. Now, where are we going to go?
By the way, sorry, I have to cut in because I do not like to be, not honest. So dishonest about certain stuff, especially like this one. So I looked into what data was telling about us, this measurement that he does. And if he was right about the very bottom line, then, by the way, this works. So according to mathematics, the line of saw, the draw a sign could work for this.
Needs to be a right angle triangle.
Measurement, it could work. It could work. The problem is that actually that I was wrong when I said that it shouldn't work. It could work, but the problem he has was what is Bev saying, by the way, that you cannot know data, and you already explained it, by the way, when you were talking to Bev. You don't have the bottom line for your car and for the bottom of the mountain at the same place. It's actually a slope. It's not a straight line as you draw it. So you actually don't have a right angle anywhere in your measurement in your real life. You can try to draw it that way, but you did not have it in real life. That's the actual problem. So I was wrong about the calculations, because this could work, but this is not what you experienced. That's the real problem. So Bev was right. The simple problem you have is you do not have the right angle.
I did it exactly as demonstrated, plus I can recite it verbatim out of my mouth exactly. So listen, dude, I know how the calculation works. I did it in reality. I know how this particular scenario is calculated, what its purpose is. I know how to derive the angle B, which you still didn't agree, which I can prove again. I was correct. How to derive angle B, because you admitted that it does work.
That's that's what I'm saying. I was wrong about that.
So listen, I did everything correctly. I did everything correctly, and
data
in denial.
You did not do everything correctly.
No. I
did everything in the demonstration provided to me by the professor, and I just duplicated in reality from my own existence.
Okay.
Can I point out, because he's gonna, I know what he's gonna say. The 9 meters and the 17 meters that he has means that when that line gets extended in a straight line to the bottom of the mountain, if you form a right angle from that line, you will not get a vertical distance of the mountain. And that's what this is relying on. But because he doesn't have equal elevations on that bottom part of his triangle.
Throughout the whole thing, you should have equal elevation. That's when you could talk about a straight line on the bottom part.
I understand, gentlemen, but again, the way I understand elevation and angles, if I increase an elevation, my angle changes. So in other words, it doesn't care what the height of the object is in the distance. The angle to the observation.
That doesn't. The angles don't mind. Yeah, the angles don't give a shit.
No,
what gives a shit is your right angle triangle that's associated with it.
Sure, it's not 100% going to be accurate in this particular case, right? As stated by the math, I'm 48 meters off, right? But it's a pretty good first measurement.
I calculated it from the beginning. I came up with 810. So,
Okay. Well, whatever, man. It's my calculus.
So it's even
formula's
more.
right there.
It doesn't
if you went-
work.
But it goes
Then
from
does it?
that bottom line goes from 9 meters to 17 meters. By the time it hits the bottom of the mountain part, it must be more than 17 meters. That is
Oh, yeah,
away
I'm not
from
trying to-
the
I'm not trying to
base
measure the
of
base,
the
right?
mountain.
You're basically measuring the height of that mountain from your position, and that's what you're doing, right? You're
Yeah, but your
you're-
base of your right-angled triangle associated with the line that you've drawn is not at the base of the mountain.
No,
Is
you're
it?
Not you're not at 0 meters. No, you're not.
No,
the
so where
angle-
is
but
it?
listen
How
again,
high up is
so
it?
So again, the angle. The angle would take care of that. Okay, so for instance,
No, the angle would not
No,
take
it
care
wouldn't,
of
by the way.
that.
Hold on. So let's say we were to draw.
Don't hold on. The
because this would
angle
work out
does
based on the
not
angle.
take
Your angle is based
care
on your
of
elevation
the
anyway.
baseline of your triangle data.
Yeah, but your angle takes care of that, right?
It
So when
don't just
when
keep
you're-
saying it. It doesn't.
Yeah. So when you are at
I know what you're trying to say.
when you're at 17 meters,
Yep.
your right angle is to the base of that mountain based on your angle. That's what that is. But from the first observer away, the base of the mountain isn't at that angle because he's at 9 meters. But his base of the mountain is
Yeah.
at that 9 meters away. That's how you get the angles correct. So those angles are correct
What?
based on each. Okay, so again, I'll repeat. Those two positions.
I don't
are
see why
all
we should keep
at
going
the-
over this bullshit.
Well, the base of that mountain would be at the 9 meter elevation for that observer. So that 9 meters would be that 9 meters for that observer, right? Because that's the angle he's measuring. He's not measuring any other angle except for the peak of that mountain. So everything along that 9 meter line will be the base of the mountain. Is it the actual base of the mountain? No, but if it was, the angle would change. It would no longer be a 6.58 angle due to the elevation. It would be smaller.
Exactly. yeah.
Right? Yeah. So but that's calculated in the angle already. Do you understand? So the elevation's irrelevant.
In
'cause
which
it's
angle is it
calculated in the
calculated
angle.
then?
The
It
height,
just
if
means
you're looking at the height
measured.
of an object. Yeah, measured, sure.
How
Just
did you
observe-
angle? How did you calculate that? In.
Line of sight in this case. So what I did is basically I had a protractor on my phone and line of sight to the eye. So I hold out just like they did back in the day, you hold out the phone and I just hold it up line of sight and I take a whole bunch of pictures, right? I can't see what the protractor's measuring. I'm only trying to accurately keep the line of sight to that peak. And then when I look at all the angles that I take, I look at the average of them. And then I take you do it in 2 locations
What?
and then you.
Yeah,
Oh,
I mean,
then you have.
dude.
I
So
mean,
you know what a
I was
quadrant
wrong.
is?
Your
Do you know what
calculation
a
could work,
do you-
but what you did,
Yeah.
Yeah,
what
he
you
hasn't got
actually
a
did,
clue.
is fucked up.
Yeah.
No, listen. You know what a quadrant is, right? So I basically use my
Data,
phone like a
please
quadrant,
Oh,
stop
mate.
it.
right?
Please.
And that's how
I mean,
divide
it's
the
for
angle,
doing
that's it.
nothing anyway, but you're just showing.
Bullshit. You want to teach people how to measure shit and use
No,
trigonometry,
you
this is
you do
great.
not teach people like this, Data.
That's okay.
You'd want to.
That's
I just
okay
taught
to
this guy
use
something new.
trigonometry.
This guy just. This
But-
guy
Yeah,
just
I
learned
mean, I
something
can
new
do that,
today,
but I mean,
okay?
But how
we'd
you
have to
how
do
you
it
came up?
properly.
But this guy speaking.
Let
is
me
man
say
enough to admit-
something.
This guy speaking is man enough to admit that he was wrong, and I taught him something today.
Yeah.
This is what I'm doing. So I'm actually going
No,
out and
I
applying this
knew
stuff
this
in
before.
reality.
I was just
Yeah, okay.
misunderstanding what
Alright.
you actually was
Alright.
writing up, by
I
the
said
way.
it like 18.
And when I
said it ad
looked into it,
nauseam.
yeah,
I said
no,
it ad
no problem
nauseam.
there.
And I said it verbatim, and I said it exactly the way it's supposed to be done. So
But again, you were using your phone for measuring based on what again?
yeah.
Pictures
So basically,
or
you know what a
an
quadrant
app?
is. Just say yes or no. You know what a quadrant is.
Okay.
Yes or no.
Yeah.
You know what a quadrant is? What is a quadrant?
Yeah.
What's a quadrant?
What?
Okay.
What do you mean?
An
How
area
do I know
divided
what a
by 4.
quadrant is?
Yeah,
It's
it's a measuring tool.
no, no,
It's a measuring
it's
tool.
a
Anyway, it
simple.
doesn't matter.
Yeah,
It doesn't
from a
matter.
An
circle.
area divided by 4.
Okay.
Sure, that's one answer for a quadrant. Absolutely. The point is that you're looking at ways to measure the
Yeah.
angle
How does it come here?
via line of sight, and there's an instrument you can have that works off a protractor and a weight the old school way. You can do a sextant. You can do
Protractor.
well, protractor works fine, dude, because it's works on line of sight and it's pretty accurate as far as, well, it's accurate as your relative 3D space, but it works fine. And look how close I was. 820 meters versus 868 meters. That's pretty close, right? I imagine if I had a better line of sight tool.
Where did you put the protractor? How did you measure with that?
Okay, so you know how you can take
I don't get
pictures
that.
with your, on the side of the iPhone, you can take pictures, just
Sure.
squeeze the two buttons, you can take pictures. So all you do is line it up with your line of sight with your hand, just like they used to do back in the day in navigating, right? They had the,
What do you do?
you line up the base of your phone to the peak of the mountain in a straight line. So a line of
Yeah, okay.
sight. So the phone and your line of sight lines up together. So you look at it's like looking down a barrel of a gun, and you're lining up at the peak of the mountain. And then when it's lined up,
Yeah,
you keep snapping a whole bunch of shots, right? So you get a whole bunch of angle measurements to better be accurate in your angles. You take whatever, you take 5 of them, divide it by 5, and you get a better, closer measurement, a more consistent one. Anyway, do that a couple of times and go from location to location, apply the law of science. And then you should, the best way is not knowing the height of the mountains and go doing it beforehand, then coming home and then finding out the size of the mountains. That's what's rewarding. It's like, oh, it fucking actually works.
Again,
right?
you're taking pictures and you have the protractor in your other hand and measuring how much you tilted the
Do
phone.
you know how you take screenshots of your phone? You
Are
take
you
your
for
own
real?
screen surface. Do you know how to take screenshots of your phone? So your phone has
Sure.
the protractor on it, right? You're not looking at any camera. You're not taking photographs of your camera. You're not even looking at the protractor because the protractor's on, but it's on your phone. And what you're doing is you're screen capturing the screen of it as you're doing your line of sight measurements, so you can see the measurement of the protractor. Are you for real?
That's based on the gyroscope, right?
Are you for real?
That's what I
Are
was
you for
asking, by the
real?
way.
Yeah, it has nothing to do with that. It's just an accelerometer. Nothing to do with. Oh yeah, well, gyro basically, but it's an accelerometer.
It's a
essentially the same
gyro,
thing.
sorry.
It's the same thing. Yeah. Anyway,
So
you
it's
just
based
hold
on
it
the
up and do
gyro,
it.
which
Sure.
differs
They have
like very
accelerometers
fucking
and they
much
have
from
gyros.
an
It's all
actual good gyro, by the way. The one that is in anybody's phone is kind of fucked up, by the way.
So I'll let you know in this week. I'm going out to do more measurements at a different location, at a different mountain, and I'll present them again to see how close I was.
Okay,
Right.
the main problem again is what Bev told you already, that you do not have
Doesn't
the
matter. Again,
line
you're not
at
listening. The
where you
angle
should have
takes
it.
care of it. You already agreed that if I was a lower elevation, I'd have a smaller angle. The angle takes care of it. I'm at a different elevation. Okay? So the angle takes
But
care
what
of
do
it.
you
So I
mean
don't
when
need
you
to worry
say the angle takes care of it?
because I don't have to worry about the height of the object and the distance based on my elevation. Okay? It's irrelevant. If my height changes, so does my angle. Therefore, I can still calculate the height of the mountain. It's not going to affect it. Right? So if I'm going,
Of course it will.
no, because the angle compensates for it. Do you understand? The angle itself compensates for the elevation. It's already embedded into the process, dude. We're not
You will come up
calculating.
with very far away calculations than you would need to actually be able to compare the flat Earth model and the globe Earth model regarding this. That's the problem
There's no such thing
you are
as a
having.
flat Earth model, brother. There's no such thing as a flat Earth model. The Earth is a living,
Don't go
breathing
into that, okay?
realm.
But I was just trying to paraphrase something very easily. That's all. But you know what I'm talking about, right? Otherwise you understand, right?
The point is I demonstrated clearly and concisely, verbatim, what the professor did to apply it in reality. I got shot down, then corrected.
The numbers
I commend
you come
on.
up with will be off as fuck. As
Sure.
you even
I'm
admit
off.
in this one,
I'm
right?
off at 40. I'm
They are
at
off.
48 meters, dude. I'm at 40 meters
And
off.
you will
Sure.
explain the offness of your measurements by claiming that, oh, sorry, it might not be flat,
I'm not
right?
worried about being. I'm not worried about being off 48.
Do you want to have a look
bro.
at that and just see what
Yeah.
you think of that?
I'm not worried about being off 48 meters for a line of sight observation done with the cell phone and the law sign calculations.
What do you think of that?
I'm just gonna see the consistency.
As a
of it.
little
If
bit
I'm
more
off
of a
by
basic
that's what
thing for us to look at, right?
Yeah, that's what I said, that it will change, by the way. So the measurements and the calculations will be off as fuck even more, by the way.
Yeah, because the 3.9 kilometer is a skew width triangle. Neither of those triangles with those angles relate to the same triangle in any way at all. And that baseline that he has isn't even part of either of those triangles that are right angle triangles. I mean,
this is not a problem. We talked about this already, by the way.
Yeah.
If I compensated and imposed a zero elevation profile, like for instance, if I know each point distance-wise, then I could reduce the angle to the 0 point elevation, right? Are you telling me that it would change the height of the object?
No. Your calculations will be off as fuck. That's what we are saying.
Yeah, I'm just saying. Yeah,
but
you're
they're
not
not
actually
crazy off,
using
though,
the
right?
law of signs there
Well,
at all.
kind of crazy off.
That is
because
the law of sines, Bev. The law of sines formula is this: 3.9 kilometers multiplied in brackets sine
that's not the
over
law of
sine
signs.
angle A
No, that's not.
divided by sine B gives you the hypotenuse of the second angle. Pardon me, the second triangle. That second triangle is the 14.29 degrees, right? So we take that, which is just basically
You're just talking again, Data.
So this is what I get back to. This is what I get back.
I was just
Oh my
again,
god.
sine over A divided by sine over B, right? So take 3.9 kilometers, divide or times it by the sine over A divided by the sine over B.
Where's the
It will
penny
get you
drop?
the hypotenuse length.
Yeah, that's the
Take
law
that
of signs.
Take the
Then you're right.
hypotenuse length,
Yeah.
Take the hypotenuse length and multiply it.
The
by sine of the
hypotenuse.
14 Yes, which is the.
Where's
that's
the
calculated.
hypotenuse?
Okay, so the second.
The hypotenuse is a right-angled triangle. It is the opposite side to the right angle of a right-angled triangle.
When we use the law of sine calculation, which is 3.9 kilometers times it by the sine A over sine B, gives us the hypotenuse of that now second triangle that has a right angle
What
triangle.
second triangle?
So the
What?
second
Where is
observer-
the right-angled triangle in relation to that angle of 6.58 degrees? Where is the right-angled triangle related to that?
We're done now. We're off to the second observer because we calculated using the law of sines the hypotenuse of that right-angled triangle. Now you find yourself at the second observer. Which is
Which
14.
right-angled triangle? Which one?
The second one.
Which one?
The second observer.
Which one is the
Observation
one?
2.
Which is the second right-angled triangle? Which one?
Observation 2 has a right.
Show me.
Observation
Show me
2
the
has-
red one.
Oh, I'm not looking at any picture. I'm sorry. I thought you were talking about.
I've redrawn your picture into a more realistic way, so then we can see the triangles we're talking
So
about.
Bev, when you drew it in that way, are you trying to say that the angles would change the height of the object based on your
I'm
elevation?
trying to point out that you do not have a right-angled triangle.
Yeah, you're struggling, Bev. So again, law of sines is real. It calculates the hypotenuse, and you do not need a right-angle triangle.
The
to do this in this
hypotenuse is, I'll say it again,
Part of
the side opposite the right angle
Yeah.
of a
look at
right-angled
observation-
triangle. So don't talk about hypotenuse and pretend it's got
there's a
nothing to
hypotenuse
do with a right-angled triangle when it has.
So in the
It's
in the
like
law of
it's like
sines
somebody
here-
talking about a tangent and pretending it's not a line that touches a curve.
Yeah, the lines between the observer 1 and observer 2, right, do not create a right angle triangle. That's why you use the law of sines, which is taking the sine B and sine A and the known distance between those 2 points to calculate the hypotenuse of now the second observation, which has a right angle triangle. To calculate that, you need to have at least one function. We don't. We need to find the hypotenuse. So we do that by using the law of sines. When we get the hypotenuse, we now use basic trig,
which
which
hypotenuse? Are you talking about the red line?
Observer 2.
Are you talking
Observer
about the
2.
red line or the green line? Which line are you talking about as though it's the hypotenuse? Please,
I'm looking at yours
Data.
now. I'm looking at yours now.
Yeah, the red line?
So we're at observer 1.
The
We
red,
measure-
which is the hypotenuse that you are working out? The red line or the green line?
The green line would be the hypotenuse, Bev.
Okay. So that's the one that you're working out the length of.
Correct. Using the law of sines.
Yeah.
Okay, now are you ready? I take 14, it's not 19, it's 29, by the way. 14.29 minus 6.58, I end up with angle B. So,
But
the
then,
red line,
sorry, then you
let me
don't have
finish,
the
let me
top
finish,
angle,
let-
the angle B.
Let me finish. You guys are, I'm teaching you, man. I'm trying to teach you this. This is not mine, and this is exactly how they
I'm
do
listening. I'm
So
honestly listening.
angle A is 6.58 degrees. Angle
Okay.
B is the top. Angle B is the top of the mountain. Angle C is the 14.29 degrees. Okay.
Yep.
We need to calculate the hypotenuse of angle C, or sorry, well, angle A of.
But how,
the
again,
green
how
triangle.
do you get the B?
So we take
Angle B.
14.29 degrees and we minus by 6.58 degrees, and we end up with 7.71 degrees.
But that's why I asked you, by the way, like half an hour ago, why do you subtract it?
Because that's what you do to find out angle B.
No, I thought I just went
Well,
over to
the professor,
see.
when you saw the video, the professor only showed you the kind of diagram in which there is only one bottom part. This has three,
No,
as you can
again,
see.
go back.
Because
Yeah, then you didn't watch the whole video, dude. I'm not doing anything different
I
than
did.
the video. Sorry, dude, I'm not.
No, I'm
sorry,
talking
then you
about
didn't watch the
Bev's
video.
picture. Bev's picture. On
Yeah.
Bev's picture, you have three bottom lines, so-called bottom lines. Three,
Yeah,
not one,
we,
three.
we want angle B, which is the top of the mountain. So put that there. That's 7.71 degrees.
I get that.
Yeah, devise that angle by subtracting the two angles. Now, if you want to proceed next to using the law of sines, we take the known distance to 3.9 kilometers. We multiply
But mate,
it
if you
by
cannot
sine
answer,
A,
how
which
do
is
you
6.5
have B?
degrees, 6.58 degrees, divided by sine B, which is 7.71 degrees. Then we end up
I
with
get
the
that. That's okay.
hypotenuse answer. You keep cutting me off, dude. I'm telling you exactly what to do, and either you're stumbling along the way or just in
You've
disbelief,
done
but I don't know
nothing
what to tell
but
you.
talk over everybody every time somebody speaks, and you're gonna call out him.
Dude, I'm
Really?
trying to
No,
complete
no,
the
he
process
can.
of
It's
steps.
fine by me.
Yeah, I
You're
get
trying
it,
to
but
complete the
bro,
process of
It's
steps,
fine by
right?
me.
what is this for? I
You
just
can't-
need to know the penny drop moment where it's like, oh, man, this is great. I mean, you've got a few problems, but okay, what do you got going on? I'm not seeing what this is relevant to.
Yeah. Well, it's about doing this over a larger area of land with straight lines and angles. And when you have
Straight
them
lines. Okay.
and when you have them intersect with each other over a surface area, there is not going to be any curvature now, is there? So the whole point is using this law of sines exercise. in
Shouldn't be,
reality.
and that's what I told you. That's
Well,
what I told
come
you.
back-
Shouldn't be, and if you do these
Yeah.
kind of measurements and calculations, and you come up with so much
The
off
most rewarding
because of
factor
what
Whoa,
you
whoa,
just
whoa,
did
whoa.
too, right?
I've been in
You
this
come
server
up with
for a
off
while.
numbers.
I've been in this
Then you
server
will
for.
say, sorry. Okay.
I've just one real thing. Real quick, and I'm done. I've been in the server for a while, and usually when something's brought up, an idea or something, it's like we try to be exact. The things we've been talking about are millimeter accurate, and the stuff we found since then are way more past millimeter accurate. And you come in with something, and you're 40 meters off. I'm not getting it.
Yeah, so in my opinion, the only thing you could come up with after what you will do in the future is that you are off because it's a globe. That's the only thing you could come up with. But
No,
that's not the reality. You will be off because you measured and calculated very badly.
No, that's not why I'm doing it. It's not about being off. It's about applying simple trigonometry over a larger area of land using straight lines where they converge. In other words, how does straight line converge on a ball? They can't, correct? But if each measurement that I take shows a convergence based on the measurement, and that measurement is closer approximate because of the tools that I'm using, which is a line of sight and a protractor, which is, I'm not expecting it to be bang on, but for a distance of 7 miles, I'm off by 40 meters.
All right,
Well,
can
we've
I
been dealing.
Go ahead.
Meters?
can
mean,
I
that's
just
not
say
terrible.
here, right, just to let everybody know, can you explain the principles for finding angle B there with what you go through? Just run us through the basic principles of the geometry involved in your calculation to work out that angle up there. Go on.
So what I saw the professor do was end up with an angle of 12 degrees. 1 degree was 22, 1 degree was 10, the angle B was 12. The only way that I deduced that was taking the two angles, subtracting them to find that third angle. Through that
Yeah, but again,
process,
he had the same bottom line for the both of the triangles,
that's
and
how you
here you have way more.
Similar
Angle C,
triangles,
take
right?
angle C, subtract angle A, and you'll end up with angle B degrees.
Right,
Angle
okay.
B degrees, you can use the law of sines to devise the hypotenuse
Data,
of the
please.
second observer's
Please, no,
angle.
nobody understood thing there. How do you work out angle B? Simply,
Yeah, I'll
you've
just
got
say
two
again.
different
On the top.
triangles. You've got two different right angle triangles, but you've only got one angle of one of them. The other one, you're missing a portion of the angle because your angle isn't taken, is it? Where's that bottom angle taken from?
All angles are from the two observers. The third angle is deduced from taking the two observers' angles and subtracting them to come up with a third angle.
Okay, so it's the distance really that you're trying to work out.
Do you see the picture that Bev posted? Data, can you see it right now?
He's wrote down underneath how he finds that angle, but I mean, I can't really
Oh, he did,
understand
then
how
he
he's
certainly
just
saw it.
took 14.29 and took one. He's just took one angle and took the other one out of it.
I know what you did, man. No problem there. With what you did is no problem.
Two angles, and
The problem is that you
subtract them,
didn't
end up with angle B.
you,
Right?
you didn't draw the right
By
diagram
the way,
for what
did I
happened.
tell you that it's not mine, right? I did tell you that, guys, right? This is what the professor did,
No.
right?
The guy had his own diagram for what he was doing, and you did a measurement, but your diagram didn't represent reality, what you actually did. You get that? And it's fucking important,
So-
by the way. We learned
Well,
that. I mean, I learned
I
that.
understand the
To
elevation
have a very good
change.
drawing.
I understand the elevation changes are important to you, but again, I'm going to reinforce.
And that changes
it.
everything. And that
Yeah,
changes
no, it doesn't,
everything,
because
yeah.
Your angle compensates for it. So if I wanted to
Your angles don't compensate.
for elevation, yes, they do. Your angles change based on elevation. Yeah, 100%.
Yes, but how does it compensate by itself? Or how? I don't get that part when you say
Because
that.
he already
all.
knows the value that he wants to end up with at the end.
I don't know any value. That's the process of using the law of science to see how accurate they were. Now, granted, the other gentleman's correct.
By the way,
I'm not bragging
the way
about
you
being
explain
off
what you
48
did,
meters. That's not the point. The point is using these
The
straight
way you
lines
explain-
and law of
okay.
science to do a grid over an Earth to show a plane that doesn't match curvature. That's all I'm trying to do.
the way you explain what you did, that you took out your phone and you used a gyroscope, basically, it sounded fishy as fuck because you said No, that's an app. That's based on a gyro in your
So what?
phone.
It's the same principle as a quadrant, man. Like a measuring, like a.
The way
an
you
angle
explained it tells me that you probably didn't do this at all.
Yeah, dude, it's all good.
Can
So,
I
you
just
can
go
go off
over
with
the
whatever you
fact
wanna
that
think
you
about.
said you want to you want to make sure a plane doesn't match curvature. Is that what you said?
So what I wanted, well, what
what I
I'm
was getting ready
using
to-
is using the
Data.
the globe.
Did you say the entire purpose of this is to show that a plane does not match curvature?
No, to show you that the 8 inch per mile square doesn't work. Because if I'm going from different sections,
That you
and I
you
turn
just
in-
changed your words. You said plane and curvature, and not 8 inches doesn't work.
Well, that's what I'm trying to show is the 8 inches don't work. That's what I'm
8
trying to-
inches doesn't work. I mean, it doesn't do anything. I mean, what
Yeah,
is
but I
it meant
wanna
to
do that
do?
in a practical, I want to do that in a practical demonstration using the law of signs. Intersect my line of sights to different places, and then show even if the measurements are off, it's not going to. There's nowhere going to be anywhere near.
Right.
the ball.
Okay. Well. All right. Brilliant. You sort that out.
Congratulations, you've taken us like 5 steps backwards tonight.
I'm sorry you feel that way. At least the other guy learned something new.
Nobody
What's
learned
up?
anything new.
I
Data.
didn't learn new. No. That's not what I told you, by the way, at all. I told you that I was misunderstanding what you tried to represent. And if you remember, I asked you, how did you come up with angle B? And it's still a question.
Yeah, and again, I've told you guys 8 times already. Would you like me to tell you for the 9th time?
No.
Subtract
I've
that
literally told
connection.
you 8 times.
Not
Would you like me
to
to tell you
subtract.
9th
Okay.
time? 9th time?
But that's
I've already told you. 9th time?
that's not an explanation. That
You
function
take
that you
angle C, you subtract angle A to get angle B. That's the function you do to develop that angle for the law of sine.
but
That's what I saw
that's
done.
not
I'm
within
just repeating what's
trigonometry.
done. That's what I saw was done. That's what's repeated is done. It works out in practicality. Bring it up with the guy who invented it.
You didn't do what he did.
It's the same calculation. I just did my own in reality. I didn't take a supposition of 2 angles. I actually did 2 measurements in a known distance. And then I applied it, and I was 48
That's
meters
okay.
off. Whoop-de-doo.
But
Yes,
Whoop-de-doo.
You had different
Whoop-de-doo
elevations.
Whoop-de-doo means we're in here every day dealing with people getting down to brass tacks talking about millimeters.
Sure.
And you're 48 meters off
7
to
miles,
prove
7
something.
kilometers. Yeah, 7 kilometers. Yeah. Measuring 7-kilometer distance.
That's
between 2
that's
observers.
really huge.
Yeah. It
I'm
is
not
huge,
even
yeah,
kidding, by the
sure.
way.
It is. 48 meters is a lot. It's a lot of feet, right? The point is that I'm going to get better at the measurements. I just came to show you that they actually do work. They're close, right? They're very close. So for archaic ways of measuring compared to what we have for line of sight technology, I'm using my own line. And granted, I could do better, actually. I could actually put it on a stand and actually kind of like make it even more precise, right? Like,
Well,
you know,
Come in the next
line of
live
sight
show.
measurement.
Come in the next live show and waste another hour of our time next time. Thanks.
So learning the law of sines is a waste, is it? Learning that you can calculate the hypotenuse using the line of sine.
No,
you
that's
need a
not a
right angle triangle?
problem. And
Well, then
that
what's the
wasn't a
issue?
problem in the first place.
Yeah, it is the problem.
The
It came
diagram
back
that
to
you
seven.
draw, you think that's your diagram regarding your measurement. It wasn't.
So my measurements that you see there, the ones that the 14.29 and the 6.58 are my personal measurements that I've taken at a location where I live, right? Now, it was the first time I've exercised the line of sight, which is like, again, not the best way, which I agree 100%. It's not the best
Okay, okay.
appropriate way to get line of sight. But I was pretty
Yeah.
I was quite impressed with the results, considering I actually didn't know how far away that mountain was and how high it was. Now, the reason why I was impressed is because I was under the impression that I needed to know at least those 2 factors. That's why I brought it to the tables, because I realized, through this math process, I actually don't need to know the distance or the height, which the whole time I thought I did. That's another reason why I brought this to the tables, just to see how you guys would respond to that. And you guys responded poorly, because at the end of the day, you can.
You were testing us, were you, Data?
Well, again, Bev, this is your show, right? I'm here to see what you guys actually.
You're here
know.
to test
And
us.
And if you're telling me that you needed a right angle triangle to calculate the height, I just proved that wrong.
I
using
said,
the law of sine.
I said,
Didn't know the
for
distance, you didn't
trigonometry,
know the
you
height.
need a right-angled triangle.
Yeah, which is that? Which is that? The distance or the height? Which comes first?
I don't know what you're
point
talking
of my-
about. Trigonometry.
Exactly. Yeah, you can say right angle all you want. You either need the height or the distance to make that right angle. The point is that I use the law of sines to calculate the hypotenuse of the second observer's right angle triangle. And through that, I can devise the apparent
hypotenuse?
height. Again, let me repeat. I was under the impression that I always needed to know the height of the mountain and the distance to it to find its angle or its height or whatever. I needed one actual known factor. But in reality, using the law of sines, I don't. All I need to know is the distance between two observed points in those two angles, and then I can get a rough approximate of the height. That's the law of sines. That's what I presented here today. So I'm sorry that you feel like you wasted the show. I'm here to show you that, no, you guys, the whole time you're telling everybody you need a right angle triangle to deduce information, and I just showed you don't.
For
That's why I'm here.
trigonometry data, don't get us wrong. For trigonometry, a right angled triangle is crucial, fundamental.
It didn't say it wasn't. I'm just saying you're saying.
Yeah, you did. Yeah, that's what all I've said. You know, you come here to sort of explain that you don't need a right angle triangle when you've just said you do.
According to you guys.
Yeah, for trigonometry, a right angled triangle is fundamental.
Sure, I'm not saying it's not.
Okay,
The point is,
brilliant.
you don't need it. You don't need it to calculate the distance or the height to a mountain, as proved and demonstrated by the professor's classroom demonstration. and my
Yet,
practical
you
example.
keep talking about calculating a hypotenuse.
Yes, using the law of sines.
But a
That's what it's for, yeah.
hypotenuse is the side opposite the right angle of a right angled triangle.
Ding, ding, ding. But you don't start with one, do you? Now, if we don't start with one, how do we use the law of sines if we don't start with a right angle triangle? Well, we try to calculate the hypotenuse between those two angles of that right angle triangle. But we don't start with one. That's your contention, right? And I'm saying, okay, look, through the law of sines, you don't need a right angle triangle. To start. To finish, you do. To start, you don't.
Right. So now we've done that again, like Buster says. We've wasted our time trying to work out why you want to work out the height of a mountain that you already know the height of.
I didn't, Bev. I didn't know the height to anything. I actually came home and had to search it up. That was the whole reward, is actually just using the basics, the basics of what I had, which was, the law of sines and some measurements. That's clearly the whole intention and purpose of the exercise. But fundamentally, it's all straight lines and angles.
I'm sorry, but if I brought something into this room and I was 48 meters off and said, "Hey guys, found this, but I'm 48 meters off, man. We need to work with this." I don't know if anybody in here would jump on the bandwagon. But now if you're in here to refine an argument for whatever reason, that's fair enough.
I'm just telling you, man, they tell you that you have the error by even if it's only, let's say 0.5% error. They will tell you that it's because of the globe, because of the radius.
I hear you, but okay, so here's the two arrows here. One arrow is being able to calculate the apparent height of an object using the law of sines without a right angle, right? That's done. Now, the accuracy, yes, I agree. It's according to real life data, it fails, and that's probably due to my actual precision measurement, right? How precisely I measure things. I'm looking to have these line of sights interject to a point where along two axes of x and y over a distance, you would have to have some sort of curve. But if I show that there is actually rising and angles, straight lines and angles intersecting heights between all those points of elevation, or angles of mountains at the height intersecting with each other over a radius of 8 miles.
I'm going to take this minute where he's muted and say he's brought this as flat Earth data with a phone and a protractor measuring angles at long distances and got 48 meters off. I'm going to make a prediction that the next person that will bring this up will have a theodolite over long distances with the same argument.
No, I think you forget. They were initially surprised that you could measure the height of something not using a right angle, right? We weren't necessarily discussing the accuracy of that measurement, although that's definitely, I'm not going to hand that in as like, hey, look at my final result here. It was more importantly just getting very close to the approximate height without knowing anything about that mountain except for the distance between the 2 points and those 2 angles. That was truly the exercise.
Sweet. Great. Awesome.
So that'd be something you want to try, brother, because it'd be good for you to know unless you already know how to do the law of sines.
I don't. I'm more interested in water level being the baseline and measuring sub-millimeter accuracy.
Well, there you go. But they're going to still tell you that is.
I'm more interested in how you got the formula to work out your 14.29 minus 6.58. Can you tell us the principle involved behind that?
So there's 2 known angles. You want to find the third. The principle behind it, I wouldn't know the principle because I was taught the exercise. The exercise showed that that's what you do. Have I gone beyond why they use that method? It would probably be because it works out to calculate the hypotenuse. Other than that, if there's any other methodology that is applicable to it, then I'm sure they would have expressed it. But it looks like it's really that easy where you just take angle C and subtract angle A to get angle B.
Right, well, yeah, and I mean, it does really seem simple when you do it like that. But can you tell me the principles involved around how you do that?
Since they're ratio based, I'm certain that would help calculate the third point of that triangle if I had the known ratios of that triangle. And so in this case,
I was very honest, right? Like half an hour ago, I told you that I was wrong. Can you be the same?
I have 2 known ratios, I guess. So if I want to know the third, well then don't I subtract those 2 ratios to find a third?
A ratio?
Well, wouldn't that be the
you don't have ratio, you have angles.
There's only one angle on that one triangle. The other one's an external angle, but it doesn't really relate to that triangle in any way other than it has one similar side. But that's a hypotenuse to just a random side of a random triangle, right? There's no really any relationship to it at all, other than, I think, a very strange case that what you've done actually works when you work out right-angled triangles. There's like a massive coincidence involved in that, but you don't seem to understand how.
Okay. No, again, it's what I said, like, I don't know, 10 minutes ago. He doesn't have the right diagram.
That works, though. That angle that he's got, 7.71, if you take the 2 triangles of right-angled triangles, one with 14.19 and the other one with 6.58, and you work out the 2 top angles of those right-angled triangles and subtract one from the other, then you do end up with 7.71.
Yeah, but you don't have that. I mean, he doesn't have that. Yeah.
Yeah, I was saying, like, it works geometrically to work out with that number, but his calculation of how he finds the number, it bears no relevance to it other than it just seems to come up with the same number. I'm keen to know if there's any geometric law that allows you to do that.
Well, it's just
Data, do you see the
ratios, right?
difference
If you have-
in between
if you have
your
two
diagram and
ratios,
Bev's
then you
diagram?
need-
Do you see
you
the
have two
difference?
ratios, if you have two ratios altogether, three vertices, and two ratios, then why can't you define the third vertice with the two other ratios? Why isn't that so hard to understand?
No ratio. You have angles. No ratios.
Well, angles. Sorry, but angles is the same. It's just it's the same thing. It's still a ratio of a degree, right? So, I have two vertices. Why can't I calculate the third by subtracting the two?
Those are within two different triangles. That's why.
There are 3 points of vertices. There are three angles. Why can't I use the two to
What?
find the third?
Two angles, not three. Two.
There's three angles, bro. There's
On
angle A,
different.
angle B, angle C.
No. We are asking the angle B.
Yeah. So if I have the two known ratios,
So you have two
why can't I,
angles.
or two known angles? Why can't I find out the third?
Because they are not within the same triangle, and you do not have the
Why do you say that when I show
good
you that it works?
correlation in between those two triangles to find a third one anywhere. That's why.
So it's just happenstance. I happen to calculate the third angle correctly, or angle B correctly. Is that what you're saying?
No, you were way off, and that's why your calculation is way off at the end. That's
So
partially
how
why.
are you calculating angle B then?
From the diagram that Bev is showing you. No how. You cannot. Not from this.
Yeah. So you have to take
Yeah, from my one you can.
Angle C, angle A, and subtract them, and you'll end up with angle B.
I'll give it you now, right? 14.29, and then the 90 add up together. Take 180,
okay.
minus that away from it. That top angle from the green bit, the other side of B, 75.71.
Yeah.
Right? Then you take 6.58.
81.
Then you add the other 90 degrees and you do the same, and you end up with 83.42. You take 83.42 and then subtract 75.71, and you get left with B, 7.71 degrees.
And that's my calculation.
That's using the two right-angled triangles. Now, what you've done is took an outside external angle that seems to bear no relation to that original triangle where you've got
you're arbitrarily adding two 90s. Why would you do that?
Because they're right-angled triangles that they're associated with.
Yeah, but they would cancel each other out, and then all you would just subtract is the leftover.
What?
So I don't know.
They cancel each other out.
If you have two 90s and one has 90 plus and one has 90 plus and one has the other 90 plus.
I'm not sure if you are following what Bev
And you're going to
said. by the way.
subtract them. If you're going to subtract them, well, he's adding 90. He's adding 90 degrees to make the angle, right? That's what he's doing. He's adding
No, I'm trying to work out the other angle at the other end.
by adding two 90s to the two equations, right? The two measurements. Pardon me.
No equation. We are simply calculating from 180 that we know that every triangle has 180 with it.
You're adding two 90s,
That's
which
what.
will cancel each other out, right? Meaning the only two numbers you really want to be working with are the two angles, which is the 14.29 and the 6.58.
No. That's why I asked, do you see the difference between your diagram and Bev's diagram?
Well, he wants to add an
Between
elevation
your
profile.
representation of what happened and between what Bev drew you. Do you see the difference?
Well, Bev is putting in elevation profile. That's all he's doing.
No. Those are
Yes.
different triangles. The bottom parts on your
adding
ones are
elevation.
sharing the same line. On Bev's diagram, they do not share the same line.
Sure. So the distance between them would change based on the elevation. The height wouldn't change the angle because the angle compensates for the height. So what? The distance may be a little longer. because if you have a slopey, hilly road, you're gonna go a little longer than. That's why I actually marked the car, because the car would be the actual road distance. So that is actually taking care of. That's actually taking care of any kind of undulation, right? So.
The 6.58 wouldn't be right, as you can see.
Well, it's right for that location because that's what's measured.
That was measured, but you said that you were on different elevations when you measured 2 times, 2 different elevations.
Which the angle takes care of. If you change your elevation, your angle changes.
I still don't get that.
Well, that's what it is. If I'm lower to the ground, my angle's going to be smaller, right? Right? And if I'm higher up, my ankle's going to be bigger, right? The point is the angle to it changes on your elevation.
If you are closer to the ground, your angle is actually going to be bigger, by the way.
Sorry, no, your angle would be smaller because it's sharper.
Well, wait. Would all this stuff make would all of these inaccuracies that he's asking about with your elevation change, would that make this more accurate if you did it without the elevation changes?
No, it would mean my tools would make it more accurate. My line of sight, the technique that I'm using.
So you don't think those? You don't think? Go ahead. Sorry.
No, I don't think the height of the mountain measurement would be reliant on my elevation, like the height of the.
Your hypotenuse. We pointed this out days ago. It's your hypotenuse. You're basing those 2 points that you're taking angle measurements from the same straight line, and it's not the same straight line, and your measurements off by 48 meters.
Right, which you would probably want to do with better instruments to fine tune that discrepancy.
Yeah.
From,
so you've taken us. Right? So all you're doing is refining an argument for somebody to come in here with a theodolite, saying they can do long distance measurements, pointing up at a mountain. So thank you.
Yep.
I'm
not into doing anything other than, like I said, using the law of sines.
Yeah.
Yeah. You keep saying that. Yes.
Keep saying it.
We know. We know how the law of sines works.
Okay.
Buster, what you just said, that they will come in here with theodolites, that won't work because Data used a gyro.
But he's laying it down for them. That's what he's saying.
Yeah.
Right?
Theodolites do angles, but they're only for short distance within the instrument, what it's designed for.
No, they have done long-distance angular measurements, right? And that's what they're talking about. Where Ranty talks about his picture that he found, they generated an angle to the mountains and to Blackpool Tower. So that's what Data's setting up here now, is that.
Gyro.
Yeah. All I'm saying is that I've seen it done with theodolites, but they do it just with short. They're only meant for within the instruments.
Yeah.
And you'd still be down with the base, right? You have to have a horizontal base line to measure your angle from. Now, is that level or is it horizontal? That's the question.
Horizontal. I need horizontal.
Right, so what's horizontal? Is that a circle?
Horizontal is equal points of elevation.
Is that a circle?
Someone is running the camera.
There's no circle involved in equal points of elevation. No, a circle doesn't have equal points of elevation.
So it's a straight line then. A horizontal is a straight line. And that's the baseline of all of your angular measurements that you're going to take as your zero, and then you're going to lift the angle from that.
It's all about straight lines and angles over a distance of 8-mile radius, all sort of converging into, like, I want to.
Sorry.
So basic.
A distance of what?
A circular disc, a flat circular disc of radius of 8 miles.
Where's that?
Straight line radius.
Where's the circle?
A radius is a straight line. it's basically going to be a town center of a place of where I live. It's going to be a town center, and I'm going to work my way out of there, measuring the angles to the mountains using straight lines. And the way I look at it, it should be an interesting, because it's all straight lines and angles, right? So it should be intersecting and then matching and then having all the degrees measured. So it's like, I don't know, man. I just see it as like making a grid of straight lines and angles, really, and using the law signs to map out all these points of mountains from this centerpiece, and then see what it looks like on a map after I build it.
Okay, but you have to keep in mind that if you are doing the measurements from different elevations, and those elevations, the next one's gonna be bigger than 7 meters, right? Because you had 8, 7 and 9 and 17,
Here's
so
the
that's
thing,
8 different,
like
8 meter
again,
difference.
You're
gonna get a bigger
you'll
one,
see that
so
it's
your
just
error is gonna be
straight
bigger.
lines,
Then
man.
you're gonna measure a bit different angles. Then your error gonna be even bigger, and so that's what you have to keep in mind.
I'm not going to be deterred from it because I had so much fun doing it already. I can't stop. All I'm going to do is have so much
No.
fun.
I'm just saying you have to keep it in mind. That's all I'm saying.
At the end of the day, I'm not a landscaper, or I mean a land surveyor. I'm just using the way I look at it is, because part of my book, as I'm learning how to navigate with your body parts and just with sticks in the ground kind of thing. And like basic tools they used in the day, right? Like making a hollow tube. And then anyway, just a whole bunch of basic navigation stuff that I want to document for the practical use of, right? Because it's really a straight line angle world that we live in, and we navigate, we build, we construct. And it's funny because Jesus Christ was a carpenter, right? So it would be all straight lines, angles, beautiful example of how to look at the world we live in and analyze it using straight lines and angles. So that's kind of like the whole purpose of
Well, I
it,
mean,
really.
that's a different question, but yeah, by the way.
Well, that's what it's all about. It's about looking at reality with straight lines and angles, right? Where the most people, I don't know, like fight the flat earth and all that stuff is all a show at this point. They know perfectly well what straight is versus horizontal, and maybe heaven forbid they actually don't. Like that would be just really absurd.
Well, you know how the Illuminati, the Freemason logo looks like, right? Everybody knows that. A ruler and what is the other one called?
Compass.
Looks like an eye. It looks like an eye if you turn
Compass
it on
in the
its side.
square.
Yeah. So they know exactly, by the way.
Gematria, gematria, the word gematria in Hebrew or Jewish, that is actually geometry. That's what gematria is. It's just geometry in Jewish form.
Yep.
I learned that recently. I was like, no fucking way. I was learning about some ancient alien teaching or ancient angel teachings in the Kabbalah, and they're talking about this geometry, magical geometry stuff. So.
What is magical geometry? What the fuck?
It just means sacred geometry.
Yeah, sorry, I meant sacred geometry. But
That's what I heard of. Yeah.
They something to do with language too, numbers, and how to put that stuff together, and symbols, right? Certain visual symbols and stuff. So it was here before us all.
That's a good one, but where did you find it?
Internal angles, it should say. It should say internal.
Why internal? What kind of have external angles?
For the numbers. For the numbers.
Oh, for the numbers. Yeah. Well, it's funny because if you look at the modern English language, sort of kind of confused it all, because I think the Greek alphabet itself, the way it's spoken in numbers, is actually related to geometry. Like the way it's related to geometries. It's really cleverly designed, the communication system. So.
Yeah, and it's even deeper with Hebrew, by the way. So the Greek is quite, how should I put it? It's quite encrypted. So it has different levels that you can crack up. the language itself and the numbers that they use or whatever they actually use in their language. But the Hebrew is even deeper. It's very interesting. But where did you find this, Bev?
I've had it for ages.
Or did you draw it, maybe?
No, I didn't do this. I mean, but I have had one like this for ages. One of them had, had the numbers wrong, yeah. But yeah, it does need added internal angles on it rather than the...
That's exactly what I was talking about, yeah. That the, how funny it's just, yeah.
The 9 is a bit off, right? But all the others are fine. Because you have to make another little angle at the very bottom of the 9. Yeah.
Well, speak
yeah,
truth.
so when, all I'm saying, Data, is that you have to look out for, fuckers telling you that you got your arrows because of the radius. That's what you're gonna face with at a certain point.
I'm not worried about this. Like I said, this is if anybody in the later years ever picks up a book that I wrote and it's in there and they go through the story, at least they're going to walk away with something to apply to it. Because everything I've learned was based on an understanding or an argument, and usually the way I learned the argument is use the own material against that individual that thinks they know the material, right? It's kind of like the I don't know everything either, by no means, not at all. But I find that sometimes going through that process, you figure out, what's what, right? And so it's good. It's good to encounter challenging situations.
Yeah, what was that, Buster?
I lost my train of thought. Sorry.
Speak truth. See, looks like he's trying to drum up some business. No, I think we know who Speak Truth is. He won't bother coming in because we know who it is. And
that's the guy that envisions bendy water, right?
No, it's not. It's not that Speak Truth. I don't think.
Oh, okay. The water has to be bending. It just has to be bending.
It has to be. Yeah. It just has to be.
Should open a whole bunch of flat earthers should open a bar called it Bendy Water.
They were arguing. He was arguing, or they were. Him and somebody else was arguing earlier about being able to curve a datum point.
Yeah. Yeah, that's
How
good.
big is the datum point?
It's a point.
It's a point.
It's a very, very, very large point. Then you can bend it.
Yeah, you can have a curved datum point.
It's already got a little bit of a curve on the top. It's a big brass bolt.
What's a button curve? Is it?
I'd say they'd hang a plumb bob on it to get it right in the middle of it. If it was me doing it, I'd guess.
It's a pretty eventful night. I'm not too keen on the law of signs as a actual way of doing anything, right? It's a very good mathematical procedure for teaching you how to use trigonometry, but it's just a mathematical exercise.
Yes. Did you know why? I'll tell you why I wanted to use it. It's because I wanted to go out and see if I can measure the distance to something and the height to something without actually knowing it, right? And so through the law of signs, you can do that. So I just wanted to exercise that because I was always under the impression that I needed to know
You
that.
can't just
For
measure
instance,
angles.
I'll give you an example. So
You can't just measure an angle.
So as a hiker in the mountains, if I had a map
And ignore.
and those maps had height elevations, right? I walked out.
You've got contour lines. Yeah, all maps have them.
Yeah.
Yeah.
So through those contoured lines, I can know the height of it, right? So let's say
And the steepness.
Sure. Let's say I'm somewhere on the map, and I can see the map, and I can see the mountain in the distance, and I know the height elevation. I literally can hold my fist up to it, and if the mountain covers the length of my fist, that's about 10 degrees. That's an approximate. It's not an exact calculation. So I can take that 10-degree calculation, take the height of that mountain. So let's say it was whatever 700 meters. I would take 700 meters divided by the tangent of that 10 degrees, and I'd get the distance to it, right? But that was on the premise that I had a map that had the height, so I could do that calculation. So I said, well, wait a second. What if I didn't have a map and I still wanted to know the height of it? What could I do? So I did a little digging. I was like, oh, the law of science. Let's try it out, right? Law of science says that if I have a known distance, I still have to know a distance. So in this case, I could take two measurements. I walked, and I have two markers, and I knew at least I had to know the distance between however I walked.
You walked. Data, please. Don't give us walked.
In this scenario, I drove. I'm just thinking as a hiker or someone, you're trying to measure the distance of something.
No.
Or just using basic straight lines and angles determining reality, right?
No, you'd be back down to being a fucking mile is a fucking 1,000 paces of an infantry soldier. I mean, no.
5,280 paces, yes. I understand that. I'm just saying that in this particular case, what could you do if you didn't know the height or the distance to it? Could you measure? And yes, you can using the law of science. That's what I'm taking away from it.
You cannot measure the distance and the height of something by measuring an angle.
No, you need to know two angles and the distance between them, or else the law of science won't work.
Again, I'm not finding the relevance. Like if you're a hiker out and you were like going to maybe avoid a mountain and you're like, man, yeah, okay, I can do blah, 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 XYZ, sign, blah, blah, blah. It's 800 meters. I don't want to scale that, so I'll just go around. It's not worth it. I mean, okay, great. Have at it. But what you're doing just does not seem helpful.
When anybody learns that they can calculate the height of something or the distance of something based on 2 points in a known distance, as opposing to only knowing that you have to know at least the known distance or the height, or the degree and the height.
Yeah, you'll get people obfuscating the fact that you can measure the curvature of water level.
Yeah, exactly.
Or the drop of a mountain over distance. The curvature.
Looking through an auto level for 10 miles. I mean, it's not helpful.
That's why I asked him how did he actually measure the angle, and he told us that he measured it by the gyro within the phone.
Line of sight.
Not pictures.
Yeah, line of sight.
Yeah, line of sight. Yeah, we hear that.
Line of sight. So if
You're
you line
saying
up
that,
the
but that's not what
protractor,
happened.
Yeah, he's
so
like
if you
he's
line up
laying
your
the
arm in a
framework
straight
for
line-
other people in the future.
How am I teaching people the law of science?
No, you're saying line of sight, and you didn't do line of sight. You waved your phone in the air.
Okay, so what I did is I lined up the phone to my line of sight. Right? So I looked at the mountain, and I lined my phone like a barrel of a gun up to it.
What focal point did you use?
My human eye, 24 millimeter.
You lined your phone up like a barrel of a gun.
Well, let me rephrase that. The barrel of the gun is sticking outward in my hand, and I'm lining the side of the phone up to the line of the sight. So you're looking down the barrel of you're looking down the side of the phone to the line of sight of the mountain, right? Just line of sight, man. That's it. Very simple.
Man, you use the gyro.
Well, protractor. I use a protractor. That's technically the protractor would probably do the
gyro.
same thing.
Yeah, I mean, I can totally imagine putting my phone up against the protractor and taping it to the protractor,
There's no phone next to no protractor.
That's what it is.
There's no phone next to the protractor.
I can see that, and you're like, you tilt it. You tilt that phone until you get it to 6.8 degrees, and you take a picture. I mean, I
6.8,
get
yeah.
it.
Yeah. That's not how it works. It's like what you guys know the instruments they used to use. It has a bar on it, a wooden bar on it, and you'd lift the wooden bar up next to your eye. So you'd have it's like having two handles, one handle next to your eye, one handle outward from your eye. So you're looking down that barrel.
Sextant, you mean?
Well, that's a sextant, but there's another one. I think it's not a sextant. It's a wood one. You can build it yourself. I can't remember. the name.
Yeah, what's his name over in Jim
Um,
Panis talks about? It's an old Roman one. I
Yeah, so
forget
I'm just
the
looking
name
at
of
that kind of stuff, right? Because I'm just looking at basic navigation, and how to deduce distances, measurements. That's it, and using line of sight technology, right? Which is your eye.
You didn't do
Eh.
that. You used the gyro in the phone.
Well, a gyro would work the same. The gyro would work the same as the
No.
normal protractor. Yeah, it would.
No, it
So
doesn't.
if I took a quadrant and had the string and a rock and a protractor, because that's basically what a quadrant is and then you had a straw along the top of it, and you lined up the straw with the line of sight, the string would dangle down in a way over your protractor. You could take a measurement, right? And that's what a quadrant would be for. So
That's
it's a
what you
measurement.
did.
Yeah, but that's the
Can
same
I
thing
just
did.
point out? Sorry, I just point out the chat's talking about
Sure.
Batman's talking about rivers flowing uphill. Well, that's a globe Earth claim, been claimed by 3 people: Nate, Zanuck, and I don't know, somebody else, but definitely it's a globe Earth claim. Rivers flowing uphill, not SE. SE does not think rivers flow uphill. However, Zanuck does think the mouth of the St. Lawrence River is meters higher than the source. Zanuck, Glober. Do you know the St. Lawrence River? Do you know where the source of the St. Lawrence River is?
I have no fucking idea.
It's the Great Lakes in Canada. That's where the St. Lawrence River is, the river that flows to the sea from the Great Lakes. Now, Zanuck thinks that mouth is higher than the source. Zanuck.
But it's not.
No, the mouth can't be higher than the source, can it? The source is in the mountains and the
wouldn't think
river
so.
flows downhill. Yeah, I mean, everybody knows that.
Oh, it's an argument, I guess, that Coriolis makes it work, right?
I don't know. Like, I don't know anyone who'd think that water flows uphill, other than Globers. Surely SE might want to come in, or is he not here at the minute? While he's away,
No.
people in the chat are saying that SE said something ridiculous. I'll defend SE.
Yeah, earlier Speak Truth said something. Oh, I saw that too. Oh, to go back.
Gently thinks that because they say north, that's uphill. I mean, I don't know who says that, Gently. You think north is up? That'd be
That's
fucking
what it was.
ridiculous.
North is up.
Wow.
In elevation,
Gently,
is
yeah.
two or what?
Uphill
That's
is
what it was.
north.
That's what I was looking for. It's, the north being up. Yeah.
Wow.
Oh my.
Gently.
Okay, that's another level, I guess.
Yeah. It was. Who was it? We had Zanuck doing the uphill rivers, and that was funny as. But then Nate came in, and we asked Nate about it. Nate said, "Well, I can't verify Zanuck's uphill, but the Mississippi road goes uphill, doesn't it?" And we went, okay then.
Yeah, I heard
So, like-
claims. I heard claims
Yeah.
like that, but I never saw the elevation difference in between the where it comes from and where it goes. So you have to know that for that, right? So
Well, yeah, the elevation has to be mapped, I think. I think it has to be mapped on a globe model in order to make them think that water flows uphill. But yeah, it's a globe Earth claim, not a flat Earth claim. I've never heard that.
do the elevations make basis for such a claim?
The elevations, the actual elevations.
Yeah.
Well, I'd see. This is where you come up against it. I mean, what is elevation? Elevation to me is when water finds its level and you measure from that level an elevation up from sea level, right?
Yeah.
Well,
Sea level.
water flows downhill. It never goes up. It wouldn't do that. Like, so, I mean, it's an impossibility in reality, right? I mean, in reality, water flows downhill. We know how water flows.
No, I was actually asking if I didn't check the elevations, but have you heard that maybe it works because they signed the elevations so that it looks like it could work? You know what I mean? They changed the numbers just for that kind of area, the elevation, because nobody fucking cares. Nobody lives at the middle of the root of the mystery or something like that.
No,
So nobody really cares.
I don't know. It's just globe earther claims. I mean, they say all sorts of stupid shit. This is just one of the things. Rivers flowing.
Well,
I think it's
as a side note, just hang on. Just as a side note, in the chat it says, "Appeal is north." Oh, what was it? He said, "Oh, E. Michael Jones says ask Xanax," and they say no need to appeal to authority. So if Xanax their authority,
they don't need to appeal to that even.
that's pretty bad.
That's pretty. Sorry.
Yeah,
I was just going to say that
Slayer.
they say that it's a straw man, but I mean, of course they're going to say it's a straw man because it sounds ridiculous, but that's their claim.
Yeah,
It has to be.
they said it. I've never said it.
My model dictates. Nah.
And then when you tell them, okay, well, this is what your model dictates. No, that's a straw man. Oh yeah, because it sounds fucking stupid. That's why. I agree. It's stupid.
Well, it was Bullet Bill earlier today was said, we went through the whole infinite drop thing, and he was like, what's wrong with that? It's like you keep measuring drop, but you're in the same spot every time you move.
Yeah, and if I'm somewhere else, then I can measure drop from there too.
Yeah.
Fine.
Over and over.
No
but you never
problem.
you never get down to the ground, but you keep measuring physical tape measure drop. So no problem.
Measure and drop.
Yeah.
I asked him that. I was like, you can measure it with a tape measure drop. Yep.
He's saying
back.
it again. Funny how we won't address
Oh,
them
my.
saying that rivers runs uphill. I don't know, speak truth. I don't know. The only people I know have said rivers flow uphill, Nate and Zanuck. And there was someone else as well. I can't remember it, but I just put the video in the chat earlier. You can watch it whenever you want. It's on my channel. Uphill Rivers. We had uphill rivers and rolling balls. That was Zanuck in the. That was where he did the LIGO balls rolling downhill to the centre and the uphill river, all in one sitting. And then Nate, obviously, because we were. You get into a conversation with the Globers. It's only the Globers that have been in this argument for so long as well. They have to say it. Forced into saying it and defending their brothers because their brothers have said something and they can't go against one of their brothers. Brothers in the globe.
I think that Speak Truth guy is broken. He keeps on repeating the same thing.
Yeah.
It's Larry, I would say.
Yeah, that's what Larry tends to do, isn't it? Come in,
Broken
Larry. Come and have a
record.
chat. It's all right.
Yeah. No hard feelings.
Yeah.
I mean, most people have sock accounts.
Jump on the Larry account and come on in and have a chat.
What? Jump on the... He should come in here. Well, I mean...
Jem Panda can come in if he wants.
He won't. He gets really, really butthurt over
Yeah.
elevation and curvature.
Jem will have been done. Yeah, well, and the triangles with 180
Oh, yeah.
degrees.
Last time I talked to him, he got really triggered over that local level.
Yeah.
Local flatness.
Yeah. He was saying you can't tell over small distances.
At a point, right? That's how small their small distance is. At a point, because it curves
I
from
got the
that
picture
point.
for you guys. This is what it would mean.
Yeah, it's Donegal. Yeah.
Yeah.
Yeah, that was one of our... the Donegal was very early on as the conceptual shape that they have to have.
Oh, how do we take the Donegal to the next step with that? I mean, is that like... I don't know.
Oh, you can take the Donegal into as many dimensions as you want.
Well, if you took it to the next dimension, it would be like almost like the disco Donegal.
Yeah. Disconagon.
Disconagon.
Yeah.
Disconagon.
Yeah, I mean, I did have surveyors supposedly on Twitter telling me that it is a disco ball. Each one of them are like a mile square.
It should look like this.
Yeah, that's what I said. Like, we've got a canal at 27 miles. There should definitely be a line somewhere where we can tell where those joins join up. Well, there should be quite a few of them on the canal.
Speak Truth is saying, why do you struggle to understand the globe model? He's asked that like 3 or 4 times.
Yeah, I mean, if you don't struggle to understand it, we understand it very well. All of its flaws and everything, we see everything about it. If you're talking about the geometric model, that's what we do here, geometry. And that's where they struggle. That is where they struggle. Geometry be the fall of the
And
globe.
using rods instead of measuring rods.
Special rods, special sticks.
Special rods, yeah.
Oh yeah, that's what it was. It
I
was
mean-
yeah, special sticks. That was what it was earlier. Forgot about that.
Magic sticks.
Tell me more about your
I mean,
special stick.
Gandalf is a surveyor too, right? He has a kind of good stick.
Yeah, that's what it is. He's like
Gandalf.
He feels a bit left out because he hasn't got one.
He lit up his tripod, but he didn't have his special stick.
Yeah.
Well, he's just mad. I guess he's upset because he couldn't light that up too.
Well, yeah, you can't, can you? The telescopic. If you were to put lights on them, like once you put them back together,
the wires would probably get shorts in them.
yeah, you wouldn't be able to telescope it down. You'd have to keep it full length. But I mean, you would have a big measuring rod, right? You could get quite a lot of lights on there. You could get a good light on top, flashing one. You could even get a disco ball. That'd be cool, wouldn't it?
Well, you could get a big spot like Leakey had where he was doing night surveying.
Yeah.
Just get a big
Yeah,
spotlight.
but I mean, what do you reckon about that? 5 meters tall. disco ball on the top. That'd be some
Yeah.
patterns, wouldn't it?
He would be the coolest kid on the block of
Yeah.
the surveyors, right?
Sure.
I just woke up from a nap to hear you guys talking about other people's sticks.
Yeah.
I don't know what's
Well,
going
yeah,
on.
that sound is quite bad, by the way. Yeah.
Special
To be fair, that was the name that Dr. Bob gave it. So we can blame it on Dr. Bob for calling it a special stick.
The measuring rod. But just because he hasn't got one, he calls other people's special sticks.
But on the flip side, B-Ball was butthurt enough. He went and bought one.
Yeah. Yeah, he did. It's quite a nice one as well.
A special stick.
He did. He bought a special stick.
Wow. Losers.
And he had proper inches as well. He didn't decimalize on his one. He went with the standard
Oh,
inches for.
but that's a level up.
I don't think they decimalize the inches either. They don't decimalize the feet. They don't decimalize the inches either.
You guys are too funny.
It has been quite it's quite good again tonight, but I mean, could do without the data. That's getting boring.
I think that's when I fell asleep. Actually, is when you guys were talking to him. That's
Again.
I
when
apologize. I apologize if you all were like leading something on or something, but for me, listening to that being 48 meters off, I mean, but we worked that out. I thought we worked all his problems out like days ago.
It's not. He doesn't use a right-angled triangle. They're not similar. Like the guy's example, good, and he just uses the fact that you can sight a mountain as an example for him to be able to use the law of sines, and then he draws the triangle out as Data does. But Data then goes and adds a different elevation measurement to a straight line.
But see, when he very first brought it, he's not being totally honest, because when he very first brought it, he said he had a distance measurement to the base of the mountain. And I remember I was like, I'm going to watch the video. I watched the video, and I saw where it was that straight line hypotenuse and then that right angle. And I asked him, I was like, how'd you get a right angle if it's down through the middle of the mountain? Well, I measured it to the base of the mountain.
Measured.
Yeah. Yeah, and he
No,
had
he
it
didn't.
parallel as well, didn't he? He had his 2 points parallel to the base of the mountain.
You know what it seems like? It seems like somebody finding something on the internet and thinking, can use that. Seems similar, awfully a lot like the pixel count argument they brought that hasn't been brought up in a while.
Yeah, and they bring it round
Okay, no,
to
that-
see
that's
whether it'll
totally
work.
fucked up, by the way. That's totally fucked up.
Yeah.
Yeah.
The
Well, do you
whole-
see the similarities?
It'll come back again. It will keep coming back, right?
Well,
They'll want to keep using
it's
it,
great
and they'll want to
because
keep confusing
I have
people.
all the citations you need. So anytime you hear about photogrammetry or pixel counting, come to me, because I have the citations in that destroys that argument, like within 2 seconds.
Yeah. I knew as soon as I heard it, because I had looked into it a little bit a few years back. I didn't know about some of the stuff you had, but it was like I knew enough to know they just repurposed the equation to fit something, not very well.
It's maths, isn't it? Again, they find an equation that they think they can fob people off, talk about angles and stuff, and you can hear Data when he's talking about it. It's been proved wrong, but he still keeps going. Just keeps going with it.
And he adds that he used his eyesight, which is a lie. He didn't. He
Well,
used the gyro.
You give it in a bit, he'll be using his thumb and his finger.
I'll take it a step further.
That would be good.
He's already done it. That's what he's doing. Body parts.
What?
Yeah, he said he wants
Oh,
to
yeah.
use his body parts to
That's
be
what he
able to
meant by that.
navigate. Yeah.
That's what he actually meant. Body parts.
Yeah.
Yeah.
What the fuck?
He's brought that before with his fingers and thumbs, and if you use your pinky, it's what 5 degrees. Is if you use your whole hand, it's from pinky to thumb, it's your 90. Yeah, pinky to thumb, it's your 90
Okay,
degrees.
No, he's fucking trolling.
No, I'm serious. What is it? Index to pinky, it's 30 degrees. I don't know. Yeah.
I mean, it's like, what are you doing it for? Well, to measure the height of a mountain. It's like, for what purpose?
With your thumb. Yeah, that's very fucking clever.
Yeah.
Honestly, I just got back from a call and I heard you guys talking about the measuring height of a mountain. You don't think that he did okay though, considering for the fun of it?
That's what I said, Scalpel. If he was if he was out hiking and he had like his phone with him and he's like, I'm just gonna go around that. Fine, fair enough.
Yeah, I think at least he's trying and shit. Like, why not?
That's fine, but if you came in here with an argument and you were 48 meters off and you were thinking it was going to be some type of proof, do you think it would fly?
Well, no, but like when you consider the percentage, he's probably off considering to what he was using to measure it. I think he did pretty good.
Yeah, but the implications of what he's doing overall in this arena, you don't see the.
I thought he did all right. Like I'm not thinking that I would go to try to get a Nobel Prize from it or anything. It's just a method that he's seen that he tried, and I think considering using a phone with the stupid leveling device on the phone, I think that's pretty not bad that he's only 40-some meters out.
He
But
might
that's
be
almost-
able to get funded, right? You could give him like 10 grand or something, and he might be able to get like 20 meters off or something like that, you know?
Now you're just taking what I'm saying and going with it. Yeah, no, whatever. I think, fuck, why not? I would have. I think, considering he's just using the phone, the stupid...
Yeah, I like
stupid
it.
angle thing on the phone, I think he did all right.
Did all right doing what?
Whatever he was trying to do.
What was that? What was he trying to do?
I don't fucking know.
No, well, there you go. It's like, well done. You don't get a participation effort like award. Like, well done. You tried. It's like, tried what? Well, you went out there at least, didn't you?
Hey man, he has a lot more fucking ambition than I do about it right now. So.
No, he doesn't. You're lying.
No, I think he did good. Like he's only 40 meters out with a stupid phone to measure the angle. Fuck you guys.
Oh, for crying out loud,
You think he actually did that?
Fuck, you guys are a tough crowd tonight. Oh, fuck the vinyl.
Tough crowd. Tough crowd.
Ask him to see the screenshots of the things on his phone.
We're dealing with people that are arguing over an instrument being a millimeter accuracy over a kilometer, and
Yeah,
he's
but this guy's on your side. Give him a little bit of encouragement.
I
I'm
tried
not-
to, right?
I'm not even going to respond to that.
I at least tried.
Hey, like, if anybody knows, I think I was one of the first people to be hard on him way back, so whatever, but I'm just saying.
Well, I will give you this, Scalpel. You did say the other day he was right, where What's Up did the same thing. And that's fair enough. And I don't know much about trigonometry, but I remember the first time he brought this, I watched the video.
Wait a minute, I don't even know what you're talking about now.
The other day he had it, and you
Law of
went and looked,
signs, yeah.
you went and looked it up, and you said the same thing that What's Up said. It looks like he can do this, guys.
Yeah, I said it yesterday or the day before.
Yeah. And that's fair enough, but I watched the video the first time he brought this and was like, this ain't adding up. It's not.
Different.
Yeah. That's not what he's claiming to do. Two
Honestly,
different
when he
things.
starts throwing numbers out, I just glaze over. But if he really did do what he says he did, and he really got what he said he got, I think, yeah, good enough for him. I mean, to do that with the phone, the accuracy, to get that kind of accuracy, just holding your phone up and looking down it, like how the fuck did he even get those angles?
Well, let me ask you this, Calpel. If you're going to bat for him in a sense, you're going to bat for him. And you're saying, no, you're going to bat for him. And you're saying, good on you. What for? What would you glean from that? That would be.
Well, did you not hear me? Did you not hear me say, well, if he really did what he said he did and he got the accuracy he said he got, then good for him with the phone.
Yeah, but for what?
Well, I don't know. What's he say he did and what kind of accuracy? Like I said,
Oh, now you're trolling.
Why am I always trolling?
Because now you're just flip flopping. You're giving him a pat on the back.
No, I'm not. What I say, I'll say it again. I'll be super clear. Okay, if he did what he said he did and got the accuracy he said he got, using a fucking phone to get the angles that he said he got, then I think he did pretty good.
For what?
Whatever he said he did.
He didn't do that well at understanding the law of signs.
I'll hand that over to you guys. So yeah, because I don't know.
Why? Doesn't it make sense what I said? Okay, so he's
for him bringing something like that to us to have a look over, right? I'll give him credit for that because it's a geometric problem based on around triangles. But all he's ended up doing is obfuscating what the law of signs actually is, and now there are people here that do not understand. They're unsure of how the law of signs relates to a right-angled triangle.
Right.
Well, if it makes you feel any better at all, I didn't understand it before or after he started.
Yeah, but he came in saying, I'm using this for a flat Earth proof, and I kept asking,
okay, well,
what?
That's where maybe he made a misstep. What I'm saying though is if he made the measurements he said he made, getting the accuracy he said he got with a fucking phone, then I think he's doing all right.
Oh, well, let's go with Rakia. If he was going out to do a concrete slab and he said, I was using this new formula, I was 40 meters out, but aren't you proud of me?
Yeah. It's all right. I waved me thumb around for a bit, and I was close.
No, but what happens if what happens if he was just fucking around with his phone and he got, you got to put it all in perspective. We're talking about the height of the mountain.
Yeah, he drove. He waved his phone around in one place, then drove in his car to another place. Yeah.
That's what I'm saying. Odometer. But that's exactly what I'm saying. If he got the accuracy he got by saying he did it the way he said it, then I think he did all right.
Yeah, well, I could do that, couldn't I? At the side of the canal, I could dangle some piece of string out of my pocket at one end and then walk down for a bit, do the same at the bottom end and go when you'd be like, well, he did all right.
Fair enough.
Yeah.
But can you imagine, Bev, if you did dangle a piece of string and take a picture with your phone and got within 40
meters
of elevation? Yeah. No, but you can't keep using the 40. You got to realize he was measuring.
Oh, I'd be able to estimate within a meter at least. So. Definitely.
You could make up a whole load of shit and get within 40 meters of anything.
No, that's not true.
Yeah,
40 meters?
That's not true. 40, yeah, but I think 40 meters is pretty good considering the tools you use. No, honest, listen. Well, I don't understand why you guys keep laughing at me. This is
God.
bullshit.
You can tell Gods has already tried this. He's got it lined up, hasn't he?
He's been out on the road.
Yeah, the best I could get was 100 meters. So
well, you did all right.
You did all right.
Dave? Holy fuck, look at this. Even Rakia's coming in to save my ass. I must be right. I broke clocks right twice a day, anyhow.
I was being sarcastic.
Oh, you're such a prick. No, honestly, you guys, when you consider we're talking about miles and however many thousands of feet on a mountain, 40 meters is pretty close.
There's a bigger picture here, and I don't want to talk about it anymore.
Me too.
What?
I'm with Buster.
Okay.
We can
Fine,
see what's
pull
going
Billy's-
on.
Pull Billy's fucking run like Billy. This is the last time I'm going to have this conversation with you.
I'm not even gonna. I said it once, probably twice. I shouldn't have, but
okay, Billy.
I'm not saying it again.
whatever you say, Billy.
Why? What's a horizontal? What's that? Why is he split horizontal? What's that about?
What the hell are you guys talking about now? Hey, get upstairs. Go on.
B-Ball's put a thing in.
Yeah, I saw that the other day. That's not the first time he's put. Oh man, he's looking for Barry.
Look, yeah, level line is normal to plumb line, while horizontal line may not be normal to plumb line at the tangent point to a level line. What does that even mean?
I think what he's trying to say is that
He could be
data-
40 meters off.
I think he's trying to say Data did not bad with the tools he was using.
And then he's got C. Oh, it's an exam, is it? Oh, it's the difference between a level line and a horizontal line. So there's a difference, right? That's already set up in the question. Like, whichever way you answer, there is a difference between the level and horizontal.
Exam Veda? What is that? Oh, Veda. Oh, is that like Indian stuff? Because they're all about that excess stuff.
It's like you guys were drinking today.
The
Were you guys
difference is
drinking?
that they're both the same. The difference between a level line and a horizontal line is that they are both the same.
B-ball won't come in because Barry's not here.
This is the horizontal one, is the straight. Not horizontal, just the horizontal.
Horizontal. must be a broad on the side of the street. A little hoary. Barry Lane is here in spirits.
You guys are fucked.
Oh, look. Brad passed.
Brad answered after the fact. After he posted the answer. Yeah, it's A. Of course it's A.
Oh, yeah.
So you guys don't think he did okay with the tools that he was using?
If you say that one more time, I'm gonna treat you like Data.
Oh shit. Okay, I'll shut up. I was just kidding.
Look, I'll give you the benefit of the doubt. Fair enough. Like, he watched the video, he thought, I'm going out, I'm gonna put my thumb up in the air, I'm getting that angle, and I might use my phone. Cause heck, man, I've got a gyro in it. Got an accelerometer.
I've been trained by professors on YouTube. A professor spoke to me, told me to do it.
A professor whisperer.
I asked him that though, Scalpel. I was like, man, look, I've been in this server for a while. I know what goes on here, what we talk about. If I came in here and was like, boom, 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 XYZ, but I'm only off 48 meters.
That's where he fucked up, is he should have said, but Buster.
Should have fudged the numbers a bit.
I only used my phone. It was just like a rough measurement, and look how close I came. Pretty cool, huh? That's where he fucked up.
Yeah, but if he had just came in and said, hey guys, check this out, it's cool. No, he argued it for 3 freaking days.
Yeah, but that's because you guys let him. That's your fault.
Yeah, well, screw you. Well, here we go. Plain Sylvangia did it.
Yeah, B-Ball's found some definitions again.
He's just seeking approval from you guys. I mean, he needs Bev's approval.
Who, B-Ball or?
Yeah, B-Ball. He bought an auto level for Bev that wasn't good enough, so he went and bought his special stick.
Yeah, to teach,
Showed
Bob. But he can't manage to convince Bob to get one because Bob knows he's lonely. He's got nobody to hold his stick.
Bob
See,
said
You guys need
Sticky-
to understand. You guys need to understand. You guys are peers now. Like when people come to you, they're coming for approval from their peers, and that's a pretty high office to take. And you shouldn't be laughing at these poor
Yeah,
people.
God
They're-
dang it, don't come in here with sticky tape and crayons and then with an angle measurement that's 40 meters off. You won't get a lot.
He didn't
As
even.
a
He didn't
peer-
even have pattern lights on it. He didn't even make the effort.
As a peer, though, you guys are the upper echelon of peers at this point. You have to hold a higher. You have a higher authority. You have to hold a higher
No, we just have to
responsibility.
have fun. We are
Now you're just trolling.
one
Yeah, now I'm
one
with you.
responsibility for us to have fun. That's it.
At any cost.
It's a new
And laugh. By all means, laugh.
Yeah, that's it. That's what we need.
God.
But anybody that goes out and figures out the height of a mountain with just his cell phone should not be laughed at. That guy should be encouraged to do more research. Research.
Say it again.
Research.
Law of signs, right? Law of signs, right?
Right.
Law of what's the law?
Can anybody in the chat here go? I'm gonna put something in the chat. Can you just tell me what you think? What you think is said? I mean, pay no mind to what it's called. Right?
Oh, he's wanting approval from Rakia now.
Who?
Yeah, he's got his poll.
The B-ball.
Can you just
See?
have a click
This
on
is
that?
what I'm saying.
I'm
You
going to
guys
have
are
a
the
click on it.
peers. I would be devastated if I went out and did something and said, "Hey guys, can you guys check this out? Does it look good?" And you guys just laughed me out of the room.
Yeah.
I'd that'd be hurt my heart. It'd be like I talked to these guys like days on end for years on end.
Yes, it's
I
just
go
said she
out there,
thinks it's flat.
I put in an effort, I use my phone to get these angles and shit, and now they're just laughing at me.
I'm sure she said that.
Does she? Yeah. Does your missus thinks it's flat, people?
Oh, not the McGurk effect.
Yeah, she says I think flat.
Yeah, I think flat. Yeah,
She thinks flat.
Talking to flat earthers.
What does that even mean? I think flat.
He asks her. He asks her a question while she's coming in, and he's meaning to get off his chat. Yeah, I think
I'm gonna
flat.
go.
Oh, he posted.
Oh, he's like, yeah, maybe. What did she actually say then?
He's posting something that. Oh, wow.
What?
That's it.
What are you guys looking at?
Oh, B-ball's like giving you like the. You hear
Yeah.
different people hear different things. Wow.
The McGurk effect. Wow.
Yeah.
Amazing B-ball.
What does everybody else think? I mean, I just say, like I've put it out there. I've copied it a few times so people can hear what's said, and people can make their own minds up. I mean, pay no mind to what I've titled the video. I mean, I think I might put that out onto YouTube. Should I upload it? If I upload it to YouTube and see what the transcript says. Upload videos.
McGurk effect. I never
Yeah,
heard of
but
that.
we still need to hear Rakia tell B-ball good job. Come on,
The
Rakia.
McGurk effect. That's when you see somebody's lips and they're saying da da da, but they could be saying ba ba ba. Whoop they
Oh.
freaking do.
Like elephant shoe. If you say elephant shoe but don't say it out loud, it looks like I love you. I used to say that to my girlfriend all the time. Elephant shoe.
Or vacuum.
What's vacuum look like?
Yeah, go mouth vacuum to your wife when she can't hear you.
Vacuum. What does it say? Vacuum.
You'll figure it out. Just
Watch
do a
out for the
try.
frying pans.
I'm gonna try it. I'm not scared. I might try it in the mirror first.
Rakia, B-Ball needs a little assurance that he's doing good.
Like, I don't think you
told him.
guys.
Oh yeah, good job. Yeah.
I don't think you guys realize how much, like, importance other people put on your opinions. That's a serious responsibility.
Well, he's got his special stick.
I mean, I don't care what you guys think, but there's people out there that do, and they get upset when you don't agree with them.
Yeah, I mean, I guess we should give more accolades for Bev. Maybe.
Yeah.
Throw out some accolades.
I don't know what those are either.
A pat on the back for the Barry Lehman.
Yeah.
I'll tell you one thing. If I ever fucking come in here and tell you guys I got the measurement of a mountain with my phone, you guys better tell me good job.
I want to
That's all
see.
I
I
got.
want to see you do it with your thumb. I mean, there's no way I'd accept you did it with your phone. I mean, like it'd be like that far too advanced for you. That gods. You use your thumb, didn't you?
The truth be known, I probably could do it with my thumb, but I don't like to show off. So.
You'd have to size your thumb up. I'd imagine you've got a big, thick thumm. You might even get 5 or 6 degrees out of your thumb. You never know.
He's got banana hands.
I just gotta. I
You got a
fucking, all I gotta
6-degree
do-
thumb.
All I gotta do is
Good for-
calibrate it. Before I use it, I just gotta calibrate it, and it'll work fine.
B-Ball says it just showcases how wrong Bev is by
What
holding
is-
a special stick up to, I don't know.
That sounds fucking bad, by the way, every time you say it.
Well, that's Bob. Bob called it that. He was the one that called it a special stick.
Yeah, I don't know what your guys' obsession with sticks is, but
Is it
whatever.
Bob?
Bob.
Yeah, you can't get off it. Should I put it out as public straight away?
His
Yeah.
special stick? That's
Well, Bob's-
gross.
Well,
You're
he-
putting Bob's
Go
special
back
stick
and-
out in public.
Go back in Brandon's server and look at it, man. That's all he talks about is. Let me see if I can find it.
Yeah, but you're keeping your sights awfully low if you're doing something because that's what Bob did. Like, come on.
No, I mean he's the one that's messed up because he's the one that had his measurements off of sticky tape and crayons, and he got mad because he didn't have. He said, "quote." He said, "Who needs a special stick?" I can find it.
Yeah.
Who needs a special stick?
Yeah, but certainly not Bob. He's fine with his sticky tape and
he's-
crayons. I mean, he doesn't need a special stick at all.
He's special enough without a
Yeah,
stick.
he's got his tripod blinged up with pattern lights.
Definitely.
Religious zealots, yeah. Of course, there's there. Good point. Calling Rakia a moron.
Well, they see Bob knows what he's talking about.
Yeah, there's Space Pope putting nugget tears for Rakia. I'm close. Basics of science.
Guess who just got exposed? Anyone want to have a guess?
Flat Earth data?
I don't know. B-Ball's made a video about it.
Oh, I bet you it's you, Bev.
People always make videos about me. I don't think I've watched any of them, to be honest.
They're
Oh, here it
more.
is. Rakia,
Yeah.
can you tell me why you need a special stick? And Kid isn't name calling; it's simply dismissive.
Nah, no. Leave it.
Oh, here's another one. So answer the question, Buster. Why a special stick? Is it magical or something?
Yeah, magical special stick.
It grows. Does that
He
make it
hasn't-
magical?
Yeah.
Come on, Buster. Why do you need a special stick? What's special about it? Is it magical? Same question I'm asking for 10
You
minutes.
should have told him when he said that. You should have told him it got your wife pregnant. Does that count?
I think disco ball on the top has got to be the way to go.
Yeah.
at night time as well, not just like a daytime disco ball, a proper
Oh, he can
nighttime.
use his lights. Yeah.
Yeah.
Nah, leave it.
Yeah. That's,
Answer
that's
my question.
Dead
You need
right,
to-
Brad. Yeah, yeah. Plane surveying, absolutely. I'm loving that. The plane surveyors, you know, all of the tools we use for plane surveying, all of the first order measurement tools, they're definitely plane surveying tools. And then
Samson, no.
oh, that's it. Yeah, sorry, all tools are plane surveying tools. So geodetic ones have got don't know, Google Earth. Is that what the geodetic surveyors use?
Is it?
When they're not plane surveying, obviously.
How much time do they spend geodesic surveying?
They've just changed it. Everything's geodetic surveying nowadays. They all do use the plane surveying tools. If that's the signifier.
They just changed the name. The old beat and switch.
Yep. That's why I've got the thing on my wall with land surveying on it. Because I can guarantee you there's not going to be any other land surveyors anywhere.
He says you're not a surveyor.
I'm not a surveyor, I'm a carer. I do have a land surveying certificate on my wall, though. I mean,
I mean something.
yeah. Yeah, nobody else. Guarantee you, nobody else has a land surveying certificate.
Oh no, I'm not talking about the certificate. I'm talking about the fact that you hung it on the wall.
Oh, yeah, of course they have to hang it on the wall. Trigger. It doesn't trigger them as much when they hear. I've done a Dr. Becky.
I haven't heard that name
I
for
have my
a bit.
pictures on the wall.
Have you not?
Account?
Not for a bit.
Have you not seen the contradiction one? I brought that one back out again for us.
It is pretty funny.
Here we go. 33 seconds worth of
pure gold.
Yeah.
Yeah.
Wow.
You might. That was amazing.
There you go.
Sorry, surveyors. I mean, geodetic surveyors. Do they really use 3D scanners in GPS?
They use LiDAR and all sorts of stuff nowadays for mapping and.
Yeah, they use GPS a lot too. It's quicker. That's all. That's the reason why.
Yeah,
all
all
the hard work's
GPS's
been done.
all GPS does is put you on a map. Your elevation data you receive from GPS is from that map.
Mm-hmm.
It's not the GPS. The GPS doesn't give you any elevation. There you go. B-ball. I've already claimed I'm not a surveyor. I don't know what's the big deal? I've got a surveying qualification for land surveying. I am now a carer, and I've got a water level test to prove a straight line. I mean, it doesn't need many qualifications, but the experience I had has served me well. People should come in and have a chat.
I mean, at least talk about why he's pointing the auto level out to the middle of nowhere.
Over water.
Yeah.
Like, I mean, what does that do? It's like data. I mean, what do you think, Gods? Do you think B-Ball did well?
I mean, we could give him
pointing
a
his
pat on the
auto
back.
level over the thing at the buildings on the other side of the water.
I didn't see it. I don't know.
Oh, now you don't want to give B-Ball a pat on the back. You just data.
Well, no, let me see what he did. Wow.
Look, he's
Yeah.
got
Oh,
he's
he
got
posted all of
he's got a picture there. So yeah, he's got another one.
Hold
Look,
on.
there's a guy stood with a With a
Where are we
stick.
looking? In general? Or in live stream?
Live
In
chat.
the live chat. Yeah, look.
I mean, he's got a picture of.
Hold on.
a
Is that the
blurry-
guy in the beach?
Well, yeah, but
Yeah.
if you scroll up, he's got a picture of a blurry special stick.
Oh, that's
And then-
Rakia's picture.
No, it's not.
No.
He wanted approval from Rakia.
Oh, that it is. Yeah.
He was
okay,
showing.
that's
He was
the-
showing Rakir his pole.
his special pole.
Oh, you mean
Yeah,
this
blur-
pole? Look at my
Blurry
pole.
and focused. Yeah.
Is that him holding the pole?
I don't know.
Is that someone else holding his special pole?
Yeah, it might be.
Well, they got the poles right, so it's not a 9-foot lad.
Why is it so tall?
What the?
How far away is he?
Oh, now you want to be skeptical.
I
Where's the
would.
pad on-
No, I listen. I said if he did what he did, if he did what he said he did with the tools that he said he
Not again.
used, he did okay to get 40 meters off. Now, if you want to start talking about an auto level or an optical level, there's certain procedural uses on how to use it, and if you don't use it that way, well, then that's a different story. But there's no procedural.
Well,
like
you don't
what
see the
that is.
pictures?
Yeah, I see a guy standing on the beach with a fucking 50-foot fucking
Yeah,
piece of wood.
go up a bit further, and it's like 5 meters, but I don't know what that is.
Yeah, whatever. It's tall, yeah.
15 foot, something like that.
Okay, so go up further where it says guess who got exposed, just got exposed.
No. Oh, you mean this pole?
And then there's a blurry one that looks like I don't know, like a lance. Looks like to me. It's got like a hand.
Oh, I see what you're talking about.
Yeah.
Oh, I went up further.
He gave you
There's
all
one-
the information you need, so give him a pat on the back.
Look, yeah, look. I mean,
Yeah, but he
there's-
can't see nothing on the pole for fuck's sake.
You can on the one underneath it. When you focus it, you can see the pole, and when you focus it, you can't see the pole. I mean, it's like, yeah, that's what the surveyors do.
Brilliant.
Okay, so all right, so he's got a measurement on the pole. So
Yeah.
now what?
Well, then he can just relate that to the mountain, to the buildings in the back, and go, look, 11 foot something.
That's what the buildings are. They're 11 feet tall.
Yeah. The crosshair. I mean, I think that's what he's doing, but I mean, I don't know. They don't explain much. Look, he just took 2 pictures. Say well done.
So he's-
Say well. Come on,
so-
like, look, he did well. He's took some pictures.
He's trying to say
He's tried.
pictures are 11 feet 3 inches and a quarter tall.
He
Is that-
doesn't
was
know
that
what
it
he's
was?
trying. We don't know what he's
Yeah,
trying to
3 and a
say.
quarter.
We haven't got a
11
clue.
foot 3 inches and a quarter tall is what the buildings are.
I think what they do is, right, they throw those pictures up. It's a bit like data. They throw an idea out there. They wait for us to discuss it, and then they'll go, that sounded stupid. Ooh, they sounded confused about that. We might take that on. Ooh, that was a good point. They thought that was it. Well, we'll have that. Definitely. We definitely meant that. And that's how they do it.
Well, I think he should come in here and explain what the pictures mean.
He won't, not unless somebody like Bob or Larry come in, then he'll.
Yeah.
He,
Well, I'll
he was
change-
actually. He was
I'll
actually
change
looking.
my name to Bob and Larry if that helps.
Well, he was looking for Barry Lehman.
Barry Lehman.
Yeah, that's what I heard. Yeah.
He's
Yeah,
our
he
top
was
guy
around
at the minute.
not that long ago, right?
Barry's our top guy.
Tell him to come in here and have a conversation with me. I don't know much about any of this stuff, and I think that Data did a good job, so maybe B-Ball can get a good job out of me too. Maybe he can teach me something. I don't really know fuck all about any of it. You think he'll come in to talk to me?
Maybe. We'll all have to be like super quiet and let you guys have your.
Yeah.
Oh, we know that ain't gonna happen, so I guess he's not coming.
Well, I'm
Yeah.
I'm not going to have a go at B-Ball. I mean, he's the one that's been having a go at us from the chat, and I'm not literally not bothered. I'd rather have him in here than we can have a chat, talk about it.
Well, I could try talking about him if he wants to come in here. He could explain to me what he's doing, and I don't know. I could ask some
He
questions.
probably doesn't see you as a peer. It'd probably have to be like Rakia.
Yeah.
Well, all the more reason he can teach me.
Like, what's he? Something showcases how wrong Bev is. I don't know what. Oh, is that the video?
He's got the crosshairs now with the buildings.
I think it might be the video is showcasing how wrong I am. Oh, look, there's another one. See, look. See how many pictures he's taken?
Half a building, Earth's a sphere.
He should come in there and talk to me. He could teach me. I'd listen. Maybe he could convert me even. Maybe.
Oh, maybe. Yeah, well, maybe you could see him as a peer.
Maybe, yeah. Even if he doesn't see, yeah.
No, he's playing basketball, as always. He's playing He's playing basketball. He can't come and talk. He's just texting. He can only text while he's playing basketball. He can't talk.
I know I do shit when I'm in here, and I think talking's way easier than texting when I'm doing
Well, I would imagine if you're playing basketball, talking must be a lot easier than texting.
You would think so.
Yeah, usually you're in here sanding or hammering.
Yeah, right now I'm looking for a fucking recipe that I can't find for the life of me. I might have to wing it. I'm looking every place for it.
Just all you need is a pinch of garlic.
Yeah, there's garlic in it for sure. More than a pinch, too. The recipe is actually for sweet or honey garlic. It's a honey garlic recipe. Oh, I think I might have found it too. Let me see here. Come on, baby. Where's my honey garlic recipe? This is a recipe I kind of made myself. Here it is. 3/4 of a cup of honey garlic or honey, 1/4 cup of soy sauce, 3/4 cup of brown sugar, 1 tablespoon of garlic, 6 tablespoons of vinegar. If you want to make I was just gonna say, if you want to make awesome honey garlic ribs, that's the recipe right there. If you're making short ribs.
I'll tell you what, the chat's on point tonight. I will say that.
What happened?
Playing b-ball and texting. Did you get benched? Playing ball with your daughter. Gravity. Maybe he is sitting on the bench. I'll play with you in a second, hon, but first I have to tell someone on Discord they're wrong.
Nice.
Is the bench level?
Is it a curved level or a straight and flat level?
Yeah, 3-pointer. Every one of them's curved. At a point, see, Brad's got the tangent problem. Jose's taught him really wrong about his at a point, because the horizontal at a point is the tangent at a point, which is anywhere, everywhere. You're not reenacting the thingy scene, are you, from...
Are we on YouTube, by the way?
Yes. Yeah, I'm getting ready
Oh,
to
snap.
wind it down, though, I think.
So everybody heard me stick up for data then.
Yeah.
Thanks for the
Everybody
head.
heard.
Thanks for the heads up, you guys. Nice friends you are. Oh well.
What, did you not want to be seen supporting Data?
Well, it's not that I support him. I just think he did okay considering
he
if he
came
did
back
what he
in.
said. I know. I fell asleep. I went on a
he
nap.
just
when you
came
started.
back in just a minute ago.
Oh.
He's gone now, though.
Oh.
So you could have told him. He might have come back for a...
I'm going to tell him if he comes back. He did okay. In my books, he's alright.
Yeah, we're gonna have to go over the Euclid, definitely. See, perpendicular. How can you have perpendicular to a point?
What's the gravity vector?
The gravity vector is vertical.
Yeah, that's what I'm saying, but
perpendicular to vertical is
Oh,
horizontal.
okay.
But he's
Yeah.
saying it's horizontal at that point, but you can't have perpendicular at that point. The perpendicular is a line in relation to the vertical.
Say perpendicular again.
Perpendicular.
Yeah.
No, when Bev says it, he's like, perpendicular.
Oh.
But I mean, if you have a horizontal, that line stretches out, and every line on that would be perpendicular to the horizontal, vertical, and parallel.
Yeah.
Oh, Mobius is on it.
Yeah.
Brad will not.
Yeah.
Not gonna happen. You went way too far.
Too many words.
Yeah.
Yeah, it wasn't just for Brad.
Oh. That's like a big book, and people usually flip to the middle with pictures.
Yeah, we know, Brad. So perpendicular. The point is, we said to it ages ago, in geometry,
spherical. Sorry.
Perpendicular.
That was funny.
Yeah, you can't have like horizontal line as long as it's any length. It can be extended in a straight line at any length. You know, a terminated straight line. I mean, it's one of the propositions, isn't it? Postulates. Postulate 2. That any terminated straight line may be produced at any length in a straight line. And then you've got a horizontal, and then you can do the perpendiculars, which will all be parallel. It's really, really simple. But all they've got is you've just got stupid people that can't understand perpendicular is.
They are measurable, not. All verticals are parallel, says Autodidactic. They are measurable, not. Is it Yoda now? They are measurable, not.
What?
In the live chat.
Geometry is just constructs on paper, can be applied to Earth, yeah? Yeah. Yeah, I mean, what's the point of just writing it down on paper if you can't apply it to reality? F.E. Slayer again. Geometry is independent of the Earth. Yeah, very true. But it is Earth measurement. It's how we measure things on the Earth. It's back to geometry is just concepts on paper. I mean, why go back to that? Puts two things out at the beginning and now he's back to it's just constructs.
Yeah, that guy's just going to go in circles. He's spinning out.
B-ball, fucking hell, you listening in? Play basketball with your little daughter, will you? Carry on. Don't worry about it. I never said it proves the Earth is flat because the Earth is not flat, B-ball. You're obsessed with flatness. I don't say that ever. Never have. Just play basketball.
It's pretty funny. Perpendicular is a concept, but that's how you can tell that there's curve. What?
Horizontal's a concept now. Horizontal is the representation of a right line in reality. Like, what is citation needed in the middle of a conversation that he's just said horizontal is a concept, a geometric concept, citation needed? What, for yourself? Like, is that a note to self? I don't know. Obviously, you've got crazy people. Don't know the difference between reality, geometry, and how that geometry is applied in reality.
What we have here is a failure to communicate.
Yeah. Yep.
Horizontal's a word. It was made up. Yeah, it's the totality of the horizon. When you continue the horizon all the way with horizontals, the totality of the horizontals and the horizon makes the horizontal. All horizontals are parallel to the plane of the horizon. The totality of horizontals make a horizontal the horizon. Totality of.
Just a word that's made up. Definitions don't matter.
It's just made up. I mean, the fact that we can prove it, it's a straight line. I mean, it sounds fantastic because they can't prove a curve. They don't know what a proof is. They've been so far detached from reality. It must be bad. I'll get the thing. Like a perfect line doesn't exist. We all strive for perfection. Slayer. That's what we do. You're right, points do not exist. That of which has no parts cannot exist. It's a nothing. That's right, Paige.
Yeah, it's just an idea, but you can use that to calculate what shape the Earth is.
You can definitely use it to predict the size of triangles using trigonometry and Pythagorean formulas. Stuff like that. That's how you can use geometry.
Yeah, build stuff in the real world.
Show us, B-Ball, show us the surveying manual. Show me. Not just a picture that you found. Show me the surveying manual that you are talking about. I've never said I disagree with surveying manuals because I've never fucking seen one. I've seen pictures that people have said this is from a surveying manual, but they were given to us by Cosmo, who's one of the lying shitbags that are on Gem Panda's server. The ones that pretend they're surveyors. Never come and talk. Never brave enough to back up any of their claims. Bit like you, B-Ball. Show me the surveying manual, or show me where I've said I disagree with all of the surveying manuals. B-Ball, stop making claims of bullshit. You're a bit childish, B-Ball. Just come and talk. Stop making up shit. That's not a manual. That's a fucking page. Show me the manual. That's the picture that I've sent you back again, B-Ball. I can tell because it's got a red line around horizontal distance. That's a curve. Does it say true horizontal distance as well? Yeah, it does. Has anyone seen that? The one that B-Ball's just put in? Can you see that?
Sorry, which one? The first one that he did with the yellow highlights?
Yeah, but the one I put a red line round it. And yeah, I'll put it back in the chat again. They're not manuals, B-Ball. They're just pictures. Read that what that says in the middle of that red line, because I've sent it back to him. Is that a straight line?
Distance?
Yeah, the true horizontal distance is a curved line, apparently.
Well, there's a lot of people that'll disagree with it.
That's why I put a red line round it. But now B-Ball decides he's going to post the one with the big fucking red line around it. True horizontal distance is a fucking curved line. Who's going to believe that?
Hex was full bendizontal.
Looks like B-Ball must be going full bendizontal as well. I mean, that's fine. But all of his other pictures have got horizontal lines that are straight. The level lines look like they're curving. It's hard to tell what's going on. Sometimes they bend them, sometimes they leave them straight. Now, let's see the manual. B-Ball.
I think it's funny if you look at that that first picture, like the pink on there or whatever that he posted. Anywhere where it shows that horizontal line that says horizontal line, it's actually just they replaced a tangent with horizontal on the thing. But you see the horizontal line goes off into space, like you're not looking at the horizon from that point.
Yeah.
So
go. The other one goes downwards, doesn't it? Like,
man, massive download.
Yeah, into the mountain. The hell?
And he posted like, what was that? 5 sided, I don't know, adjustment for curvature.
there's that word curvature is globe.
Did you go look up mathematical definition for flat? Anybody? Probably nobody.
No, I did earlier, but there's like so many different.
Go to the free dictionary one and it's very interesting. I'll just tell you. If you put in mathematical definition for flat and you go to the free dictionary, it straight goes to curvature. It says redirected from flat.
Oh yeah. I noticed that.
Okay.
Yeah, the free dictionary definition and then curvature. Bam. That's hilarious. And it even says related to flat mathematics.
No, it says redirected.
Right next to curvature says redirected from flat.
Yeah.
And then also found in Thesaurus, Medical Encyclopedia, and then related to flat. Weird.
So if you look up sorry, if you look up flat, it redirects you to curvature.
Related to it as well, like a distant
mathematical definition of curve. Let's see what that says. Maybe that'll redirect me
to flat.
Yeah.
Where's the free diction? There we go. Nope. Went straight to curve. That's weird.
Yeah.
Is curve?
Is globe.
Yeah. Well, plane is curve. No, that's. Well, it depends how you look at it.
You just look at a hula hoop. Oh, what was it the other day? The guy. Who was it? Look at a 2-dimensional circle from the side. Who was it that did that?
Oh, which one?
Somebody posted and said, "Would you look at a 2-dimensional circle from the side?" I can't remember who it was.
That's like their favorite thing. Look at the straight line and tell me if it's straight. Now I'll make it look like a circle. Now tell me that it's straight. What?
Yeah, it's a hula hoop. Man, I hate these guys are just text chat trolls.
Yeah, text chat trolls, and then they go like, well, definitions don't mean anything, except for when we're just posting pictures of all of the definitions that we're going to give you. Right, then it's fine.
Then it's relative. Definitions are only relative to when they give them.
Oh, that's research now. Looking up definitions is research.
That dude does geometry. Look at that. A branch of mathematics that deals with.
Yeah, B-Ball, there's another picture right there where the horizontal line isn't looking at the horizon. It's just out into nowhere. Maybe the horizon is beyond that hill.
Good
in that figure.
He just posted all those while he's playing basketball?
Yeah. He carries them round. They'll be on his phone ready. He's gearing up to be a bit of a rumpus, people, isn't he? He's obviously not going to be. He's not going to be able to do it in the chats.
He's going to supersede
in the VC. He's just going to be a text chat troll. Like
he's worse than.
He's the new surveying guy.
I hate to say it, but that's like supersedes crit.
Yeah.
I mean, it's impressive how fast he can post. What's that? 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh, he's got his backup one, FE Slayer. Yeah! Earth is Life just kicked all your asses with his posting screenshots that Cosmo's found for him on McToons' website. That's all he's doing. He's just copy and pasting from McToons. Boom, boom.
I don't even think I could select 9 pictures and post them as fast as he did. That's insane. My hat's off. Scalpel. Let's give him a pat on the back. He missed that phone call.
Are you gonna troll me forever over this now?
Yeah, no. We need you to give B-Ball a pat on the back for how fast. Like, could you? Let's count down. Do a countdown. See how fast you could get 9 posts.
Look at all the lit up letters, right? And
It's
all
more
he's
impressive.
done. What he's
More
done.
impressive than what Data does.
What?
I can't even do 9 letters in any length.
No. He's got nine screenshots in one post. Bam, done.
Yeah,
Dusted.
but you can see what's highlighted. He's just done a word search for curvature, and every time one of them comes out, he screenshots that page, puts a red line around it because it's still got the curvature on it, and then posts that, and it's all from McToons' website. All of it. Yeah. Just curvature search in the word search.
So silly.
But that kills. I mean, it slays for F.E. Slayer. I mean, that's really dead good, that. That's Wiggles, isn't it? Giggles.
Yeah, Mr. Giggles and oh god, how many?
It's Flurfernerfer.
Let me count the ways. Busta.
Verticals are found using gravity. Using perpendicles usually, but whatever. Here we go. Here's some more. Look.
Oh
red
gosh!
bit. Look at that.
That's 3. Well, he had to downplay that one.
I mean, it is determining the figure of the Earth from arc measurements. That's looking at lights in the sky. Yeah. Looking at lights in the sky. That's where you relate the lines you make on the floor with the lights in the sky, and then you go, it's curve. Oh, sorry, they make a load of triangles, put them all together, and then go, yeah, the triangles are curved. We did use some curved lines on those triangles.
But even when they do that, they do it the opposite way. They call it the arc of the sky, and then you have a horizontal underneath. So, which is it?
It's surveying, B-Ball. They survey the land. It does not mean level is curved. Have to prove it, B-Ball. You don't prove it by showing pictures of things in books. People write all sorts of shit, and seeing as that's all you've got, have you got any manuals, like the full surveying manual that shows us how to do the surveying, how the surveying procedure is carried out in reality? Auto level, measuring rod, differential leveling. How does it occur? That's it. It does relate to geometry. Wow. I wouldn't keep posting those, Brad. You'll get people confused, Brad. You end up with people thinking verticals aren't vertical.
Am I not mistaken? He's got a horizontal line there?
No.
What's funny is that depending on which model you're looking at, vertical could be different.
Well, those two verticals are definitely different. Look at them.
No, I mean at the same location. Like the geoid model and the ellipsoid model have different verticals at the exact same location. So
but
depends on.
If he's going to have that one line in the middle that's a horizontal, and he's got lines that are off. Those aren't verticals, per the definition of perpendicular.
Look at B-balls saying in surveying level is curved. I mean, somebody's fooled him badly, B-ball. That's bad. That you've allowed people to do that, and well, I don't know, and they might be laughing at you, B-ball, for getting you to say that. Then I know that they're not brave enough to say it themselves. So what they need is I don't know, what do you call it? A useful idiot in order to come out and say these stupid things. I'm not going to mock you for it. I'm just going to say it is ridiculous to say that level curves. Level is not a circle. No matter how much people say horizontal's a circle and level's a circle, and it's, you know, like some people can't make their mind up whether level is horizontal or horizontal's a circle, level's a circle, and you can measure the level diverging away from the horizontal. But then when they come to try and do it, then they have to realise that the horizontal might be the circle. And perhaps Euclidean geometry's all wrong about perpendiculars and all of that sort of stuff. I mean, maybe. But you'd have to be able to prove it with another system of geometry to build your mathematical framework on. Wow, look at this.
God, here we go again.
It's Rakia.
Oh, it's Rakia. Man, that's impressive, Rakia. I'm impressed. I couldn't post that fast.
Wow, he's gone faster than B-ball.
Oh my God!
It's all real. How much curvature? It doesn't seem to be much curvature there. That's all horizontal distance and vertical distance.
Yeah, well done.
I think I've got that same manual.
No curve, right?
Yeah, those are all.
No,
yeah,
it's all like real surveying using practical solid geometry.
Yeah, rise and run, slope.
That
kind of stuff.
Yeah, that must be tricky.
That's an actual manual.
Yeah, like nearly the full manual.
Nearly.
Yeah.
Good
Rakia
God!
must be winning. Hey, Rakia must be winning in poker tonight, guys. He's like super quick.
It's either that or he's already out.
Well, he was raking in the chips earlier, so he should be good.
Look at B-ball. What's up with you, man? Stop lying, B-ball. You've gone from even worse. So you disagree with all of surveying? No, B-ball. I know how surveying is performed. The actual art of surveying.
We've talked to these people.
Yeah. B-ball, stop fucking lying, please. It doesn't make you look good. Come and chat, and we will talk about surveying. Just stop making lies up about us, B-ball. You're going and ending up like Dr. Bob. The lying shitbag. Yeah, all like Ranty. I wonder whether B-ball disagrees with all of those things that Rakia posted. Because that's all of the sort of stuff that I'm looking at. And that's the only surveying that I ever know about. You have to show us all of the other shit.
You might have looked at it and probably saw that, you know, there's no word curvature underlined and circled, and just skipped over everything.
Yeah, he put curvature in the search for that manual, and it didn't pop up anything. So it's not of no use to him. I mean, all of those other ones that he's done, like he probably found like one reference to curvature on each manual. Because the rest of them wouldn't mention anything. It'd be all of this sort of stuff that Ricky's got. Guaranteed. That's why he can't show us the manual. He just shows us the pages that have got curvature mentioned.
Uh-oh.
Here we go again. Look. Boom. Here we go. Let's see what this says. The curved shape of the Earth means that the level surface through the telescope will depart from the horizontal plane through the telescope at the line of sight proceeds to the horizon. This effect makes actual level rod readings too large by...
Don't listen to Sean G. Gah.
Where D is the sight distance in thousands of feet. So how often do we sight distances in thousands of feet?
Not recommended.
Oh, that's right. You don't.
You don't.
You don't.
It's not on the.
Oh,
It's
right.
not. It's not on the special. You didn't get the right special stick.
You gotta get the one with the big numbers.
Are really small ones. Because the smaller you make the numbers, the further away you can see them.
Oh, it does say the typical. Yeah.
Line of sight downwards, making the lever rod reading smaller. You're not helping yourself here.
I was just thinking that.
Well, it says the actual level rod reading's too large. What does that mean? The rod readings are too large. It doesn't even seem to make any sense.
Oh, now he's got something blacked out.
Uh-oh.
I thought it was just a big, bold red line. Like, ooh, it's really big, really. It's really there.
Large areas. I can't even read that.
It says, blah, 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 curvature, blah, 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 blah.
My model dictates blah, blah, blah.
It does say a bit above that. It says purpose. Federal, state and local governments make surveys, maps and charts of various kinds that are referenced to national, horizontal and vertical datums. Oh. These datum ties are necessary to provide basic information for planning and carrying out national, state and local projects. Oh, so like normal, even in that one that you've posted there, B-Ball, I mean, national, horizontal and vertical datums. Nice. What you have to do, you have to blank out all of the other bits. Just leave the bits that say curvature, because the rest of the stuff won't help you, people. There's double talk in everything that you're going to have, that you show wherever it says curvature. How can they reference all of the maps and datums to a vertical and horizontal datum? Cartesian coordinates. This is going to go backwards and forwards. We've got this, it says curve. And we go, yeah, but we can prove this. And they go, yeah, but it says curve.
Well, even Brad's. Oh man, Brad, the Wolfpack guy.
Yeah.
Wannabe Wolfpack guy.
Fucking hell, B-Ball. How many times do you want to fucking slander me? I have never claimed to be a surveyor. I have a surveying qualification, B-Ball. You must be stupid. Is somebody else going round claiming shit for me? Because I've never said it, B-Ball. Has anyone else ever heard me say I'm a surveyor?
No, but it's
Well.
like, anybody could go get their bar card. That's fine. You got it. But that doesn't mean you're a lawyer or practicing law.
Yeah. I think the idea is just to discredit, right? And then what they want to do is they want to try and say about surveyors, right? The next one to come is always like Bev says, surveyors don't know what they're doing, all of that sort of shit. It's just all lies, people. And I know you're listening. Stop doing it. It's slander. Libel. It serves no purpose. Claiming I've said and I've claimed things I never have constantly is just fucking bad. It makes you look bad, people. I know what side you're on, and you're on the side of we can do whatever the fuck we want. It doesn't make you look good. And I don't think it'll end up you winning the argument, because if that's all you've got, false claims, then it's not going to get you very far. And why'd we end up with a load of trolls in the chat again all of a sudden? Just stating stupid shit.
Oh man, this Effie Slayer's lost it.
Mm-hmm.
We use more sophisticated methods. Do your research. We have.
Yeah.
Geodesy surveying.
It's just a straight line. I mean, why should they get so triggered?
But he says right after that, he says, why should I believe you over people that actually build stuff? Half the people in here actually build stuff. So. Go screw yourself? I don't know.
The simple fact is we've got a straight line test. They don't even know what it is because they're that ignorant of it. And rather than come and find out what the test is, they're that confident that it's a globe, they just slander you rather than coming up with a test that proves that it's a globe. I mean, I don't know why they're so upset. They admit that you can have a straight line on a globe.
I get it. If you were a shadow, you'd be mad because you're forced to do what you're told to do.
Yeah.
Whoa!
We go. He's found another couple of curvature words.
Nah, I think he just posted the same thing he did earlier.
Does it say horizontal datum?
Geodetic surveys. Geodetic systems. Coordinate systems and datums. Yeah, horizontal datum. Same one. Just a shadow.
Read it. It says, a horizontal datum forms the basis for the computations of horizontal control surveys in which the curvature of the Earth is considered.
Like.
So how they have a horizontal where they consider curvature. Well, I mean, that proves it to me. Must be a globe. They have a horizontal datum.
He posts this and it says, it's like a flattened sphere because the Earth is in fact flattened slightly at the poles and bulges somewhat at the equator. I mean, wow. It's hard to read these.
Every surveyor and engineer disagrees with you. Like, I don't know. I've never talked to anybody that in real life that thinks level's curved. Never. Not one. People thinks the test's never going to get done.
Well, see, that's messed up because you guys have been out with the equipment and you've done it on a server where people could come in and watch.
Yep.
Anybody. It's like to think that a large scale test would just be as easy as just, oh, hey.
Yeah, it's all right. We've had B-Ball say that again today, Brad.
Oh, Brad's got his
B-Ball, Bullet Bill it was.
Verticals aren't parallel.
Yeah, he's got B-Bell to back him up. Verticals weren't even vertical. They were only vertical in the middle. I wonder if that works for him as well. Look at this. It's
wow.
FE Slayer, nicely done. I've got the globe. You say level is horizontal. Prove it. Prove everything. I'll do a Google search of curvature.
Oh, we get a Wolfie.
Oh, Wolfie.
I got a good story. You want to hear it?
Go on.
Yeah.
Cashing out at the poker game. I've been there 4 or 5 hours, whatever. There's a school teacher that we've been talking, about everything. And I asked him how you have gas pressure without a container about 2 weeks ago. He said he was going to come with an answer. I've seen him probably 5 times since then. Well, today, waits till I'm leaving. Comes up to me. I got your answer. He was all excited. Ozone layer.
What?
What?
He said the ozone layer is creating a container that gives us gas pressure here on Earth. I recorded it, but I can't put it in here. It won't let me. It's too big or something. But he said the ozone layer did. I said, what's the ozone layer made of, in your opinion? He goes, gas, but heavy gas. I said, heavy gas? Wouldn't that be pulled down by gravity? I said, maybe you should rethink this and come back to me in a couple of weeks.
Heavy gas and up top forming a barrier, keeping the light gas in.
Lighter gas.
How did it get up there?
That's a teacher. He's probably 80 years old now, but he was a school teacher when he, that was his job. Funny. I got it recorded. I don't know. It won't let me. It's too big to file. It's only like 30 seconds, but it says it's too big to load here. Anyway, I might put it on my YouTube. Just download it here, and you know what I'm saying, as a video where y'all can hear him say it. It was pretty funny. But yeah, he couldn't. We sat across from each other the whole night. He couldn't discuss it with me. He had to come out to me at the end, try and take a pop shot. And right when he said it, he like runs back to his seat. You know, he don't want to talk. He don't want to keep talking about it. He just ozone layer.
B-ball posted
According
pictures.
to this surveying book, what? Like somebody's just wrote a load of text at the side. What the fuck?
Wow. Well, B-ball posted a picture from the day he actually could have come in and been there and asked questions about it, but he wants to post a picture.
And then ask, where are the measurements? Well, the measurements were on the screen.
Could have wrote them down
on
yourself.
The Discord. Yeah.
Yeah. As they were doing it. What a ding dong. It's all right.
He's too scared to come in. It's okay. People, we understand. I think I'm going to have to shut the YouTube bit down. Sorry, people. I'll be back again soon. Tomorrow, maybe. Start the